Alright, so good night to everyone, good night, good night. So welcome to Moyo Math, and tonight we'll be looking at the June 2024 Math Paper 2 solutions. So the exam has ended, the exam was on Monday, it has ended. So how was it? Alright, the feedback I got from some students said it was very good. Some students said it was a bit challenging. What I'm pleased about is the fact that a number of students said that the live sessions that we did, of course a few days before the exam, certainly helped them in the examination. So that was extremely positive. Those students who found the exam to be a bit challenging, as we go through the solutions tonight, let's hope that at the end of the session that you'll feel a bit more confident about the exam and that you will pass with a very good grade. Yeah? So tonight we're going to go through the paper. Let's start with question 1. Section 1, question 1. Don't forget, before we get into it, to like, share and subscribe to Moyo Math. Alright, so let's get into it. So they ask us to 1, calculate the value of the square root of 7.1 in brackets squared plus 2.9 in brackets squared, given your answer correct to two significant figures. So we have the square root, so we have 1a, and we have the square root of 7.1 in brackets squared plus 2.9 brackets squared. So of course this will be equal to, this is the square root of 7.1 in brackets squared, it's 7.1 multiplied by 7.1 plus 2.9 in brackets squared, that's 2.9 multiplied by 2.9. This becomes square root. Let's work out this 7.1 by 7.1. So that is 7.1 multiplied by 7.1, which will give us 50.41 plus 2.9 by 2.9. That will give us 8.41. And when we add those two numbers, we're going to get 50.41. Add 8.41. And we're going to get 58.82. And when we find the square root of that, we're going to get the square root of 58.82. will give us 7.6694. But then what they want us to do is A, to express this answer correct to two significant figures. So we can have A, so expressing correct to two significant figures. So to express it to two significant figures, we're going to come from the first non-zero digit from the left, which is 7. So we count 1, 2. That's your second significant figure. We always look at the number immediately after, which is 6. Once that number immediately after is 5 or more than 5, we add 1 to that 6 to become 7. So this will be 7.7, and we ignore all other digits. So your answer correct to two significant figures will be 7.7. So let's look at B. So we have now corrected two decimal places. So correct to two decimal places. So if we have to approximate this answer correct to two decimal places, so for decimal places we're counting the positions, but we're counting from after the decimal points. We're counting two places after the decimal points, which is 1, 2. So 6 is our second decimal place. We look at the number immediately after, which is 9. Once the number immediately after is 5 or more than 5, we add 1 to the 6 to become 7. So to two decimal places, this will be 7.67, and we ignore all other digits. So that will be your answer, 7.67. So let's move on to the next question. So looking at 1A part, this is part 1. So looking at 1A part 2. So let's move on to 1A part 2. So they ask us here to write the following quantities in ascending order. So we have part 2, so 1 part 2. We have 12 all over 25. We have 0.46 and we have 47%. So when you talk about ascending order, ascending means moving from the lowest to highest. So lowest number to highest number. So to do so, what we can do is we can first express all as a fraction, and we ensure that all our denominators are the same. So this is 12 all over 25. This is 0.46 from a decimal to a fraction will be 46 all over 100. And 47% from a percentage to a fraction will be 47 all over 100. So let's make sure all denominators are the same, which will allow us to comfortably look at our numerators and recognize which is the smallest and of course which is the highest. So we can convert 12 all over 25. We can represent this fraction as one where the denominators are also 100. So to do so, I'm going to multiply 25 by 4, and I'm going to multiply what I do to the denominator. I must do the same to the numerator. So this will become 48 all over 100. This is 46 all over 100, 47 all over 100. So all denominators are the same. So now what we can quickly and comfortably do is express it in ascending order. So in ascending order, remember from smallest to highest. Yeah? So our smallest here will be 46 all over 100. Then we're going to have 47 all over 100. And the last will be 48 all over 100. And this here, of course, will be 0.46. This will be your 47%. And this will be your 12 all over 25. Okay, let's move on to the next. So we're looking at 1 part B. So 1 part B. So 1B. Mahindra and Jaya shared $7,224 in the ratio 7 to 5. How much more money does Mahindra receive than Jaya? So to trigger this, we have some proportional parts, 7 to 5 at a ratio. 7 will be Mahindra and 5 will be Jaya. So in that order. So Mahindra and Jaya in the ratio 7 to 5. So we have this amount of money to be shared among those two persons, and it stated how much more money does Mahindra receive than Jaya. So in terms of the proportion, you can clearly see that Mahindra received 2 proportional parts more than Jaya. So 7 subtract 5 will give you 2. So what we want to do is to determine how much money will 2 proportional parts equate to. So for us to do so, we're going to establish a proportional relationship, and that proportional relationship will exist between the total number of proportional parts, which is 7 plus 5, 12. So we have 12 proportional parts. So the total of your proportional parts is equal to the total amount of money to be shared. So we want to determine how much more money does Mahindra receive than Jaya, which of course will be 2 proportional parts. So for us to determine 2 proportional parts, we are going to find for 1 proportional part, which will be to divide 7,224 by 12. And 7,224 by 12 will give us what? 7,224 224 divided by 12 will be 602. So one proportional part will be equal to $602, and therefore two proportional parts will be to multiply 602 by 2, and 602 by 2 will give us $1,204. So how much more money does Mahindra receive than Jia? That's the amount Mahindra receives more than Jia. So let's move on to the next. So we're going to part 1C. So I'm erasing here. So 1C, it states the present population of Port Mort is 550,000. It is expected that this population will increase by 42% by the year 2030. They want us to write the number 550,000 in standard form. So 1C part 1. So you want to write this number in standard form. So remember what standard form? Standard form means that this number must be expressed in this form. A by 10 to the power of n. And A simply means that this number must be more than or equal to 1 but less than 10. So it must fall within that range. So this number clearly doesn't fall within this range presently. So to make it lie within the range, 550,000, the decimal point is understood after the last 0. But this point where it is originally must move and lie between two numbers that will make this number 550,000 lie within the range 1 to 10. So this point where it is originally must move between your two 5s. Yeah? And when it moves between your two 5s, it now becomes a number between 1 and 10, so it becomes 5.5, which represents your A, multiplied by 10, which will always be fixed, and n here represents the power, and the power is dependent upon the number of positions the point moves and the direction to make it lie between 1 and 10. So how many places did this point move, original point move, to make this number here lie between 1 and 10? So it moved 1, 2, 3, 4, 5 places, and to the what? To the left. And because you're moving to the left, the power will be positive. So this will be 5.5 by 10 to the power of 5. So that's a representation in standard form. And then they ask us to, part 2, calculate the expected population of Port Mort in 2030. So what is the expected population? So looking at part 2. So the expected population, it says it is expected that the population will increase by 42% by the year 2030. It is expected that that will happen, so by 42%. So we're going to find 42% of 550,000, and 42% of 550,000 will be 42 over 100 times 550,000. My 2 zeros will cancel, 2 zeros cancel, so that will be 500, that's 5,500 multiplied by 42 will give us 231,000. Alright? So that's what's going to increase by. But what we're going to do is to add that to our 550,000 so you'll know what is the expected population in that year 2030. Alright, so it's going to increase by this amount, but then for us to identify how many persons are expected in the population within that 2030 year will be equal to, so we can state here the expected population will be equal to your 550,000 plus your 231,000. So we add 550,000 to our 231,000, we're going to get 781,000 will be the expected population in the year 2030. Alright, let's move on to the next. So we have here, right, so looking at part D, so 1D. So it states here, 1D, the graph below can be used to convert between the United States dollars, US dollars, and Eastern Caribbean dollars, EC dollars. So we have this graph here. What they ask us? They ask us to, using the graph, convert US $2 to EC dollars. So you want to convert US $2 to EC dollars. So this is your EC, this is your US axis, this is your EC axis. So you want to convert 2 US into EC. So it's a simple case of moving from US to EC. We call that interpolation, moving from Y to X. So I'm going to add 2. So I have my line. So I touch, right? So starting at 2, draw a dotted line. I touch my my line, my sloping line, representing my US on the Y, EC on the X. And what I'm going to do now is travel. So where my dotted line touches the sloping line, I'm going to now travel to my EC axis. So from US to EC. So this will be right, it's somewhere around here. Alright? And for us to determine what that is equal to, it's important for us to know what one of these subdivisions, one of those small boxes, one of those subdivisions, what one is equal to. So if you have 5 of these boxes, 5 boxes is equal to 1 unit, then 1 box will be equal to 1/5, which is 0.2 units. So every little box here, or every subdivision, proper name subdivision, is equal to 0.2. So this is 5, this is 5.2, and that should be 5.4, yeah, which will be $5.40. So we can say here for part 1, using the graph, convert US $2 to EC dollars, just a simple case of moving from the y-axis, you touch a middle line and travel towards the x-axis, moving from US to EC. So the answer here will be part 1, so D part 1, US $2 will be equal to EC $5.40, yeah? So $5.40. So they ask us next, convert EC $70 to US dollars. You want to convert EC $70 to US dollars. So this x-axis doesn't go all the way to 70. So we can't locate 70 EC dollars to convert it into US form of the graph. So therefore what we can do is just simply use a proportional relationship to make the conversion. So we know US $2 is equal to EC $5.40. So we just use this relationship here to convert 70 EC to US. Yeah? And look how simple we're going to do it. Let's use the relationship here. So for part 2, if we have to convert from EC to US, remember what you have to convert to always goes on the right of the relationship. I'm using this relationship here to help me to make the conversion. So I have to convert to US, so US goes on the right. So I'm going to start by saying $5.40 EC, or EC $5.40 is equal to US $2. So I have to convert to US, so US must be on the right of the relationship. Let me find for EC $1. So 1 EC dollar will be to divide 2 by 540. And therefore, EC $70, yeah, EC $70 will be to take your 2 divided by 540, which represents 1 EC. Once you know what 1 EC is equal to, you can determine what 1 EC is equal to in US. You can determine what 70 EC is equal to in US. So it's simply to take 2 divided by 5.40 times 70. And when we wrote that out, what are we going to get? This will be, so 2 divided by 5.40 multiplied by 70, and we should have here, so 2 divided by 5.40 multiplied by 70, yeah? So $25 and approximated in nearest cent, $25.93. Alright, so this is what 70 EC will be equal to in US, $25.93. So let's using our relationship there to help. Alright, so let's move on to the next part of the question. Right, so moving on to question 2 now. So question 2. So hoping that, the solutions, going through the solutions can, bring some ease to those who, found it a bit challenging. So let's go through, check to see what, to think you did right, and see where you can build your marks so you can pass the exam, alright? It says here, 2, Laura needs to put mesh, wire mesh, around 2 seat beds to protect her ceilings. Altogether, she uses 60 meters of mesh. So altogether, she uses 60 meters of mesh to put around the seat beds. One of the seat beds is a rectangle, so this here, and the other is a square as shown in the diagram below. So the width of the rectangular seabed is x meters. The length of the rectangular, the width of the rectangular seabed is x meters. The length of the rectangular seabed is 3 times its width. And it states here the length of a side of the square seabed is y meters. So A, using the information given above, derive a simplified expression for y in terms of x. Alright, so we have 2. So we have these 2 seabeds. You have, one is a rectangle and the other is a square. Alright? So Laura needs to put mesh around the 2 seabeds. So mesh around. So this is your seabed. And this is your rectangle. This is your seabed. This is a square. Alright? So Laura needs to put mesh around 2 seabeds to protect her ceilings. Altogether, she uses 60 meters. So altogether, she uses 60 meters of mesh. Alright? Now, if she's putting this around each seabed, it means that this length of mesh is 60 meters of mesh. Must cover the perimeter of each seabed. So the perimeter or distance around each seabed. So one of the seabeds is a rectangle and the other is a square shown. So if we know, as stated in the question, that the width of the rectangular seabed is x meters and the length of the rectangular seabed is 3 times its width, it means that the length of this rectangular seabed will be 3 times x, which is 3x. Then we can determine what is the perimeter of the rectangular seabed. So this will be, if this is 3x, you know this length here is also 3x, and this here will be x. Alright, so we can find the perimeter of the rectangular seabed. And we know the length of one side, this is a square seabed. So we know that the length of one side of a square seabed is y meters. So we know if it's a square, all four sides are the same length. Yeah? So if this 60 meters of mesh covers or if not surrounds the perimeter of each of the seabeds, yeah, and we know that it's a total length of 60 meters, then we know that the perimeter of this rectangle, which will be 3x plus 3x, that's 6x plus x, that's 6x plus x, 7x plus x, 8x. Good. The perimeter of the rectangular seabed plus the perimeter of your square seabed must be equal to what? 60 meters. So using 60 meters of mesh to be placed around each of the seabeds, and of course the total perimeters will give us that length of 60. So we know that the perimeter of our rectangular seabed, this will be 8x, plus the perimeter of the square seabed, this will be y plus y plus y plus y, that's 4y, and that will be equal to what? 60 meters. And what they asked us in this question is to, using the information given above, derive a simplified expression for y in terms of x. So what is y in terms of x? It means that you have to make y the subject of the formula, and you must obtain an expression for y in terms of x. So y may be the subject, and the expression obtained for y must involve x. So how are we going to do so? How are we going to make y the subject of the formula? So to make y the subject of the formula, we have to remove 8x first. So you're going to remove 8x by simply subtracting 8x from both sides. So you can take 8x and bring it over to the right, change the sign to negative. Or you can minus 8x from both sides. You use this balancing method. And what you do to one side, you do to the other. This is 16. Subtract 8x. So the two 8x will cancel out on the right to become 0. You're left with 4y is equal to 60 minus 8x. And therefore, to get y as the subject, to get y by itself, you have to remove this 4 in front of y. So what you're going to do to remove that 4, this is 4 multiplied by y. So the opposite of multiplication is division. So you divided 4y by 4, and you're going to divide 60 minus 8x by 4. So when the two 4's on the left of the equal sign divide into each other, you're going to get y as the subject, y by itself. And we're going to obtain an expression for y in terms of x. You see this expression has x in it. But this expression, you want a simplified expression. This expression can be simplified by simply, you can't say 4 into 60 just like that. Once there's an addition or subtraction sign separating terms in the numerator or denominator, you can't just cancel like that. The only way we can simplify this is to separate the terms. So we're going to write this as 60 over 4 subtract 8x all over 4. So y is equal to, when you divide 60 by 4, that is 15. Yeah? Subtract, when I divide 4 into 8x, I get 2x. So this here is expressing y in terms of x. Let's move on to part B. So it says here the area of the rectangular seabed is equal to the area of the square seabed. And I think, when we were doing the review sessions, we would have looked at a question just like this. I think the day before we looked at something very similar, very, very similar, same concept, where you have two shapes, and what you need to do is to derive a quadratic equation. Yes, we looked at something very similar. So it says that the area of the rectangular seabed is equal to the area of the square seabed. Using this information and your answer in A to write down a quadratic equation in terms of x and show that it is simplified to become that. So the area of the rectangular seabed is equal to the area of the square seabed, and what they want us to do is to use that information to show that a quadratic equation can be produced. So you want to show that that quadratic equation can be produced. So let's show it. So I'm using this information here. So this is B, part 1. What we did before was, that was 2 part A, right? So this was 2 part A, now we're looking at 2 part B1. So use this information, right? So we know that the area of the rectangular seabed, this is your rectangular seabed, so area of rectangular seabed is equal to the area of square seabed. So what's the area of a rectangular seabed? You know the area of a rectangle is the length by width. So that's 3x times x, and the area of your square seabed, the area of a square, you know it's what? Side by side, that's y by y. So 3x by x will give us 3x squared, and y by y will give us what? Y squared. Okay, so you have this equation created here. But remember what they asked us, they want us to show that this equation here, showing the area of the seabed of the rectangular seabed, sorry, equal to the area of the square seabed, the equation created here can be simplified to produce that quadratic. Okay, so this has to be converted into that. So how are we going to convert this into that? So if we look at this quadratic equation, it involves x only x. This equation involves x and y. So we don't want to work with y, we don't want to work with x, strictly x. So we proved and showed before that when we express y in terms of x, if we look at part A, using information, derive a simplified expression for y in terms of x. This is what we got here. This is expressing y in terms of x. What we're going to do is to use this expression for y, which is 50 minus 2x. In terms of x, we're going to use this expression for y in terms of x. We're going to replace this y, which is 50 minus 2x. And then we're going to simplify it. We're going to have the equation strictly in terms of x. And then we're going to simplify it to produce that. Let's see how it looks. This will be 3x squared. I'm replacing this y with 50 minus 2x in bracket squared. Right, so that's the only way I can get the equation strictly in terms of x. I need to replace that y with that 50 minus 2x we proved earlier. And now, what we're going to do is take this now and break it down together. So, this is testing the knowledge of what you call product of binomials and so on. So 50 minus 2x squared is the same as, that's not 15 by 50 and minus 2x by 2x. Students always make that mistake. This here is 50 minus 2x times 15 minus 2x. Alright? And the night before we did this, and what you're going to do is to multiply these two, we call them binomials. So this is 3x squared is equal to, so you're going to take 15 in this first binomial and you're going to multiply by each term in the second. Then you're going to take negative 2x in the first binomial and multiply by each in the second. So this will be 15 by 15 and then 15 by negative 2x. So 15 by 15, that is, you know, that's 225. So 15 by 15, that's 225. And we're going to multiply 15 by negative 2x, which is negative 30x. So that's 15 by each in second. Now let's take negative 2x by 15 and negative 2x by negative 2x. So negative 2x by 15 is negative 30x. And negative 2x by negative 2x is plus 4x squared. Alright? And when we simplify that, what we're going to get? Let's simplify what is on the right hand side. So we're going to get here, this will be 3x squared. So I'll continue up here. 3x squared is equal to 225. Negative 30 subtract 30 is negative 60x plus 4x squared. Yeah? And here we're almost there. So what we're going to do, this is a quadratic equation because we have variables squared, we have an equal sign. So to have it in the true form of the quadratic equation, we must have the quadratic expression made equal to 0. So we're going to make that quadratic expression equal to 0. Simply take this 3x squared and we're going to throw it over on the left hand side. Yeah, or in minus 3x squared from both sides. So and when you move 3x squared from the left to the right, the sign changes. So this becomes 0. You remove 3x squared, so there's nothing there, 0. So this will be 225 subtract 60x plus 4x squared, and positive 3x squared will come across as negative 3x squared. When we simplify that, what we're going to get? 0 is equal to 225 subtract 60x plus x squared. And yeah, that's what we have. So if you want to rewrite it in that form, let's switch it around. You'll have x squared minus 60x plus 225 is equal to 0. And what have we done? What have we done? We have shown it. So we can write hence shown. So we have shown that the area of the rectangular seabed, which is equal to the area of the square seabed, can be simplified to that quadratic equation. So hence shown. Alright, so let's look at the next part. The next part of this question says, solve the quadratic equation using the quadratic formula. So we have to solve that quadratic equation and using the quadratic formula. Alright, so let's look at that. So let me erase. So this requires you to know your quadratic formula. And if you don't know it, the quadratic formula is normally in the formula sheet. So that's a good thing. Yeah, it's in the formula sheet. So if for some reason you can't remember it, you can find it in the formula sheet. So let's solve this quadratic equation using the method of the formula. So we have here, this is 2b part 2. So we have the quadratic equation x squared minus 60x plus 225 is equal to 0. And we want to solve that using the what? Quadratic formula. So you have to know what is the quadratic formula. The quadratic formula is x, because it's solving for x, we start with x, is equal to minus b plus or minus square root of b squared minus 4ac all over 2e. So that is a quadratic formula. You have to state where, what is a? Number in front of x, well 1. What is b? The number in front of x, which is negative 16. What is c? The constant, which is 225. So let's substitute a, b, and c into our formula. This will be what? X is equal to, hold the subtraction sign in front of b. Replace b with negative 60, but I put negative 60 in brackets. Plus or minus the square root of negative 60 in brackets all squared. Subtract 4, replacing a with 1 in brackets. C, 225 in brackets, all over 2 times. I replace a with 1 in brackets. So we're going to get x is equal to a minus by a minus is a plus, so we get 60 plus or minus the square root of negative 60 all squared. Of course, it will be 3600. And this will be negative 4 by 1 by 225. So negative 4 by 225. That will be negative 900 all over 2. So we're going to get x is equal to 60 plus or minus the square root of 3600 minus 900 will give us 2700 divided by 2. X will be 60 plus or minus the square root of 2700 as the square root of 2700. You're going to get 51.9615, and it's always good to have about 4 places after the decimal point, 4 to 5 places, because it will help you get a better approximation to your answer, right? So all over 2. And at this point, we can use some keywords when we solve a quadratic equation. We'll say either x is equal to 60 plus, usually positive now, plus, that's why I have the plus or minus, you have to get 2 solutions, 51.9615 divided by 2, and 60 plus that, 60 plus 51.9615 divided by 2 will give us 55.98. Alright? So that is the first value of x. So we're going to say now or. So we always use these 2 keywords. Or, what is the other value of x? X is equal to, taking the 60, subtract 51.9615 and divide that by 2. So I'm going to get what? This will be 60 subtract 51.9615 divided by 2. So I have 4.01925, right? And what we can do, we can, if you want to leave it as 2 decimal places, right? So the 55.98, that's a 2 decimal places. The 4.019, 2 decimal places, you can write it x as 4.02. So expressing both values of x to 2 decimal places. Alright? So let me put to 2 decimal places. Okay? So we solved the 2 values of x. But what I want us to do now in part 3, calculate the total area of the 2 seabeds. You want the total area of the 2 seabeds. Good? So total area. So what is the actual area, numerical representation for the total area of your 2 seabeds? So we have our 2 seabeds. So I'm going to write these, just write here 2 values of x. Right, so we have 55.98 and 4.02 are 2 values of x we obtain, right? Now they want us to determine what is the total area of the 2 seabeds. So I'm going to erase here. So we have our 2 seabeds. We had the rectangle, and we have the square. So the dimensions for the rectangle, of course, it was 3x and x. That's for the rectangle. And the square was y by y. Right? So you know that each length of the square was y. So if you have to get the total area of the seat beds. Now, we are going to get the total area. Normally with questions as such, you'll take the values of x and substitute it into the given variables representing your length and dimensions of the geometrical shape given. And then yeah, you can get a numerical representation for the areas. So normally with questions as such like this, especially whenever quadratic, you normally see where one value is positive and the other is negative. So you know automatically your length cannot be negative. So most times you'll take the positive value and you'll substitute it into your dimensions of your geometrical shapes, and you can determine what's the area. Alright, but in this case you have two positive values. So let's see what we're going to do here. Now, previously we got y to be, previously I think we got y to be is 15. So y is equal to 15 minus 2x. Let me write it on top here. So instead of y, I'm going to write 15 minus 2x. Alright? So, if x is 55, remember they asked us to calculate the total area. So we want the total area of the two seat beds, right? Total area of seat beds, of two seat beds. Alright? So, if we decide to use x as 55.98, alright, let's see if we use x as 55.98, if we can get numerical representations for both geometrical shapes, and then we can add them to give us what is the total area of the two seat beds. So when x is 55.98 and I substitute here, I can get 3 times 55.98, and of course 3 by 55.98. So 3 by 55.98 will give me 167.94. Yeah? And of course, this x here will be 55.98. So when I multiply 167.94 by 55.98, I can get a numerical representation for the area of my rectangle. Now, when we replace x here in the square with 55.98, let's see what we're going to get. This is 15, subtract 2 times 55.98, which will give us 15. Subtract 2 by 55.98. That's 15 subtract 111.96. And 15 subtract that, you see what we're going to get here? We're getting a negative. We're getting a negative value. So we're going to get negative 96.96. So the length here is negative. So therefore, you cannot have a negative length. Alright? You cannot have a negative length. So obviously the 55.98 wouldn't be applicable to your square. Alright? And therefore we cannot use the 55.98 to help us get the total area of the seat beds. Good? So the 55.98 is out of the question. We can't use that to help us get the total area. So let's try x equal to 4.02 and let's see what's going to happen. So when x is 4.02, let's see. This is 3 times 4.02. So 3 by 4.02 will give us 12.06. This is 4.02. So obviously when we multiply those two lengths, we can get the area of the rectangle. And let's see if the 4.02, if we can get positive length for the square, of course, which will be the same for all lengths on your square. So this is what? 15 minus 2 times 4.02. That's 15 negative 2 by 4.02 will give us 50 minus 8.04. That's 15 subtract 8.04. Here we get a positive value for your length. So now certainly we can find the area of the square. So using 4.02 as our value of x, we can use that now to help us to calculate the total area of the seabed. So these type of questions, when they ask you to solve it, you know, two geometrical shapes, they ask you to prove it's a quadratic, solve the quadratic. Normally, they will ask you to use one of the values to help you to determine what's the actual dimensions of the geometrical shapes, right? And most times one is positive and the other is negative, and you go with the positive result. But in this case, both are positive, so you know you have to do a bit of testing to see which one we're going to actually use. And you see the 4.02. So, total area of two seabeds, we're going to write here area of rectangle plus area of square. And the area of the rectangle, this will be, I'll write it from what I have here, 12.06 is going to be the length, multiplied by the width, plus the area of the square. I'm going to write what I calculated there, which is 6.96 times 6.96. So when we work that out, we're going to get 12.06 multiplied by 4.02 will give us 48.4812 plus 6.96 multiplied by 6.96. You're going to get 48.4416. Let's add those two now to see what will be the total area of the two seabeds. This is 48.4812 plus 48.4416. So we're going to get 96.9228, and it's the total area, so we have to put the units, and what units? We'll use meters, right? Yeah. So we're going to put 96.9228 meters squared because it's area, right? Or square meters. And what we can do, we can represent the answer to two decimal places, so it's 96.92 meters squared with 2 units. Alright? So that's the total area of your two seabeds. Alright? So I know some students may have had some challenges, and students did complain about this question. Right? So at this point in particular, students would have had some challenges because you would have got to that point and decide on what you're going to use. But just a simple case of testing, and if you saw one of the lengths is negative, then clearly we're not going to use that substitution for x. Alright, so let's move on to the next question. Right, so trigonometry. So this is question 3. So question 3 trains. So we have here a vertical flagpole. FP stands on horizontal ground and is held by two ropes, PG and PR. So you have a vertical flagpole held by two ropes, PG and PR, as shown in the diagram below. PG is equal to 80 meters and FR is 9.7 meters, and the FGP is 38 degrees, which we see. Right? They want us to calculate the height of the flagpole FP. So to calculate the height of the flagpole FP falls within two right angle triangles, and when we are doing our review sessions, you know when we have a vertical and it meets a flat level ground. Of course, the vertical will meet that level ground, which is normally represented as a horizontal line. So that's why I say horizontal ground. It's going to meet at what? Right angles. Yeah? So we have two right angles on either side of that vertical line FP. So we want to find FP. FP falls within two right angle triangles. Which one are we going to use? We cannot use the one on the right because we do not have sufficient information to find FP. So obviously we're going to use the right angle triangle on the left. So part 1, so this is 3A part 1. I'm going to pull out this right angle triangle from my diagram. So I'll have G, I'll have F, which shall be a right angle, I'll have P, and I'll have 18 meters. And I'll have this angle of 38 degrees. Good? So they want us to calculate the height of the flagpole FP. So to find the height of the flagpole FP in a right angle triangle, we know in this case we are going to use trigonometry. We can't use Pythagoras theorem here because we do not have information for two sides to find the third. But what we have in this triangle is an acute angle on a side, so we know trigonometry will come into play with just SOHCAHTOA. That's what we're going to use, right? And before we use our SOHCAHTOA, sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite all over adjacent. We have to make sure we label the sides first. So this side opposite your 38 degrees will be side opposite OPP. The side opposite the right angle is the hypotenuse HYP, and the remaining side is the adjacent side. Then I always advise students to circle the side you want to find, which is FP opposite, and you circle the side you have information for, which is 18 meters hypotenuse. And what trigger function slash ratio connects these two sides of circle, opposite and hypotenuse? Opposite and hypotenuse will be sine theta. So you're going to write here in part 1, sine theta is equal to sine opposite all over hypotenuse, sine 38 degrees is equal to my side opposite, which is FP, all over the hypotenuse, which is 18. And to remove this equation from its fraction, I put sine 38 over 1. I have two fractions on either side of the equal sign. And to remove that equation from its fraction, once you have a fraction on the right, a fraction on the left, a fraction on the right, one on the left, one on the right, you can cross multiply to remove it from the fraction. So this will be 1 by FP is FP, and this will be 18 multiplied by sine 38. So FP is equal to, I go to my calculator, 18 multiplied by sine 38 will give me 11.08 meters. And it didn't specify, to approximate anything. So if you want to put it on 1 dp, make sure you state it in brackets. FP is equal to, but because this is the 1 decimal place, I'll put it to 1 dp, 11.1 meters, or 1 dp. Alright, so you know FP is 11.1 meters in. That's FP. So let's look at the other part of this question. It says, find PR, the length of one of the pieces of rope used to hold the flagpole. So they want us to find PR. So where is PR? So this is PR here. So they want us to find PR. And if we look clearly, PR falls within this triangle on the right, which is PFR, that right angle triangle. Yeah? So what I'm going to do is to pull out that right angle triangle. Here is here. And we're going to use that right angle triangle help us to find the length of PR. So this is 3A part 2. So let me pull out that right angle triangle. That triangle, it is F and it's PFR. This is 9.7 meters. This is 11.1 meters. And we want to find PR. So clearly this is a right angle triangle. You have information for two sides and we want to determine what's the third side. So one time we know we're going to use Pythagoras theorem to help us to find the length of PR. So in using Pythagoras theorem to find the length of PR, again, Pythagoras theorem, we always use the hypotenuse squared. So that is PR squared, the hypotenuse. The hypotenuse is the side always opposite the right angle. That's a hypotenuse, which is PR. The hypotenuse squared is equal to the sum of the squares of the other two sides. And the other two sides are 11.1 squared, and doesn't matter which side is written first, plus 9.7 squared. So PR squared is equal to 11.1 squared, that's 11.1 by 11.1, which is 12.21, plus 9.7 squared, that's 9.7 times 9.7, that's 94.09. So we're going to get PR squared is equal to 12.21 plus 94.09. That gives us 106.3, and therefore to make PR the subject, you have to remove that power of 2 to get PR by itself. So I'm going to find the square root of PR squared, which will allow the power of 2 to disappear. You'll just be left with PR. But you do to one side, you do together. So get PR is equal to, let's find the square root of 106.3. So square root 106.3. Right, so we're supposed to get here 10.31 meters. And we can approximate to 1 dp, 10.3 meters will be the length of the flagpole PR. Alright? So you use a Pythagoras theorem there. Alright, let's move on to the next question. So yes, so and again, I think the night before we looked at a question like this involving your angles. When lines are parallel, what angles will often come into play, right? So let's look at question 3b. So 3b, we have this this shape. Let's quickly redraw it here. So you have the two parallel lines. You have this transversal. You have this line going from here to here. So this is the parallel line Q. Parallel line. This is PQ. This is MN. Right. This is T. This is S. That's L. And this is X degrees here. Alright? And you have this angle here which is 28 degrees. So what they want us to find in this question? They want us to find the value of X. How are we going to find X? How are we going to find this X here? Now, the review sessions we learn when two lines are parallel and you have a transversal. Remember, three important angles will come into play. Z shape, alternate angles. This angle is equal to this angle. Those two angles are equal. You learn when there's the F shape this angle, these two lines are parallel, have your arrows. This angle is equal to that angle corresponding. And you learned when you have two parallel lines and you have that box shape, these two interior angles must add to give 180 degrees when you add them together, called co-interior angles. Right? And they also told us that so the diagram below PQ and MN, so PQ and MN are parallel, and L, so this is R here, LRT is an isosceles triangle, and SLT is a straight line. So SLT is a straight line. So this triangle is isosceles. And what we know for an isosceles, these things should ring a bell one time. You should know that if this is your angle, this here, of course, we have our two sides that are equal. Those are the properties of an isosceles triangle. So two equal sides. And of course, this is the apex of the isosceles. And opposite to the apex will be the base. So this is the base. So you have two base angles here. Bap, bap. Yeah? So those two base angles. So that should stand out one time. Look for an isosceles, two sides are equal, and the side opposite the apex will be a base. And two base angles are equal. Alright? So they want us to find x. How are we going to find x? How are we going to find x? What can we use to find x? Or, and also what is important, note when two lines cross and meet at a common point, the two angles that are opposite each other are equal. So all this we looked at in the review sessions, and this is known as vertically opposite. Angles. So I see that also coming into play to help us to find x. So to find x, what we can do, we can find, if you look vertically opposite, these two angles, right, are set to be vertically opposite. So if you find this angle here, you can easily find x. See the lines they cross, so they are vertically opposite. So if we can get these, this entire angle here, which comprises of this angle and this angle, then we can easily find x. So this angle here is easy to get because if you look, you see the Z shape automatically, alternate angles. So you see the Z shape. So if this angle is 28, I expect this angle here to also be 28 degrees. Good? So that angle is 28 degrees. And this angle here can be easy to find because this is an isosceles triangle. The base angles are equal. So all you have to do is to subtract 28 from 180 and divide that by 2. And that can help you to get this angle. And when you add those two angles, then that will be equal to x because of vertically opposite angles. Right, so they ask us to find x, so what I'll do, I'll just show you steps to get it. So you know that, let's name this angle here, angle Q. L is the fixed point, L, R. Angle QLR or RLQ is equal to 28 degrees because of what? Alternate angles. It's alternate to this angle here, which is 28. And we know that this angle here, which I'm going to name RLT, so I'll call it RLT, angle RLT, yeah, RLT or TLR is equal to 180 subtract 28 divided by 2. 180 subtract 28, 152 divided by 2 will give us 76. So this angle here is 76 degrees. So therefore x will be equal to 76 degrees plus 28 degrees, which is what? 76 plus 28 will be 104, and that will be for vertically opposite angles. Alright? So they didn't ask us to give a reason, but of course, showing the steps so you can determine how the value of x, the angle x was formed. Alright? Okay, let's move on to the next. Right, so looking at C. This is question 3C. So let me erase. So for 3C, so we have that. Right, so we have this grid here with two shapes. You have two trapezium, plural. So this is Q and that's T, right? So they want us to, let's highlight them first so we can. Right, so highlight them. Right, so you have Q and you have T. Good. So what I want us to do, they said here, describe fully the signal transformation that maps shape T onto shape Q. And again, we looked at the review sessions, we looked at transformations, and we looked at the different ways you can transform object points to image points. And in this case, the form of transformation we're going to be using, or we're going to use, is reflection in the line y equal to x. That's clear to be seen. So remember the line y equal to x, reflection in that line, reflection in the line y equal to x. That is what? That is a sloping line passing through the origin. Yeah, a right-hand slope passing through the origin. And we can prove that because the line y equal to x, just to plot the points, you can actually see the line y equal to x. This is how you simply set it up to, so you can see a line. Take all y equal to x, you're going to set up a nice table, x, y, so you can plot the points and you can actually draw the line. You're taking all the x coordinates, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, I'll stop up to 8. And take every value of x and substitute into the equation of the line. So when x is 0, y is 0. When x is 1, y is 1. X is 2, y is 2. 3, 4, 5, 6, 7, 8. Just substitute all those values of x into your equation of your line. When you plot, look at what's going to happen. 0, 0 is where? Here. 1, 1. 2, 2. 3, 3. 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. So this here will be your line y is equal to x. Good? So that's the line y equal to x. And reflection takes place about that line. So when I ask you to describe fully the single transformation that maps the shape T onto the shape Q, that single transformation, so this is C part 1, sorry, erase here, but let me write it here. C part 1, so the single transformation is a reflection in the line y is equal to x, right? So this is the line y is equal to x. Good? Let's look at the next part. On the diagram above, draw the image of the shape T after it undergoes a translation. So we did all this by the vector -1, 6. Label this image M. So we want to draw the image of the shape T after it undergoes. So what is the image of shape T? So this is shape T here, but shape T had undergone a translation. So looking at C part, that's what, C part 2. So C part 2. So shape T had undergone a translation T, and with a translation is always a column vector, or 2 by 1 matrix, looking like this, -1, 6. So how are we going to translate T? What -1 means? It means at every point T, you're going to translate 1 to the left and 6 upwards. Right? So, -1 meaning moving 1 to the left and 6 upwards. 1, 2, 3, 4, 5, 6. So this point here ends here. Let's take this point. Removing what? Removing -1 and 6 upwards. 1, 2, 3, 4, 5, 6. That's here. Let's take this point. Removing 1 to the left and 6 upwards. 1, 2, 3, 4, 5, 6. That's here. And let's take the last point, moving 1 to the left and 6 upwards. 1, 2, 3, 4, 5, 6. That's there. So you see, about that translation, the orientation of the shape or figure doesn't change. The only thing that changes is what? Position. So they remain same orientation. The only thing that changes is the what? Position. And they told us to call that what? Call that M. So this is M here. Alright? So let's move on to the next question. Right, so moving on to question 4. So let me erase this. So question 4. So we have 4. A rectangle PQRS has a diagonal PR where P is a point -310, R is a point 4 -4. They want us to calculate the length of the line PR. So that's coordinate geometry. So again, coordinate geometry. Again, when we did our revision, coordinate geometry came into play. Our review sessions. So they want us to calculate the length of PR. So we have this rectangle. This is the rectangle visual. So you have P, Q, R, S, and it has a diagonal PR. So assuming this is PR here, right? Let's assume it has a diagonal PR. Where P has a point -310 and R has 4 -4. Let's assume it, right? Calculate the length of the line PR. So to find the length of that line, or formula for the length of a line, PR is the formula, we should know the formula, square root of x2 subtract x1 in brackets all squared plus y2 subtract y1 in brackets all squared. So we should know that formula. We know we have P, whose coordinates are -310, R, whose coordinates are 4 -4. I'll always tell students to label the coordinates so you wouldn't make mistakes when you're substituting into the formula. So this is x1 y1, x2, y2. So this will be PR square root of open brackets x2 is 4, subtract x1 is negative 3 in brackets. So put a negative 3 in brackets, close big bracket square, open big brackets 4, subtract negative 3 in brackets, close big bracket square, plus open big brackets y2 is negative 4, subtract y1 is 10, close big bracket square. So let's simplify that. PR is the square root of a minus by a minus is a plus. So 4 plus 3 in bracket squared plus, of course, negative 4 subtract 10. So write it back as is. And let's simplify that now. This becomes PR is the square root of 4 plus 3 is 7 in bracket squared plus negative 4 subtract 10 is negative 14 in bracket squared. And we're going to get PR is the square root of 49 plus, we know 14 squared, negative 14 squared, that's 196. And therefore we know PR is the square root of 49 plus 196, 49 plus 196, 245. So PR is the square root of 245. The square root of 245 will give us 15.6. You can put it to 1 dp, 15.65. So I'll put it to 1 dp, 15.7. Okay? Units. Okay, I'm always going to write units because just to generalize. So that's the length of PRs. Let's look at the next part of the question. For A part 2, determine the equation of the line PR. We want the equation of that line PR. So let's get the equation of the line PR. So I'm erasing here. Part 2. So to find the equation of a line, again, you have to know your formula for the equation of a line. So part 2, the equation of PR, the equation of line PR. So using the formula y is equal to mx plus c. Remember that formula. What you need to do is just replace m and c with numbers. Y and x will stay as is in the final representation for your equation. So let's get m, which is the gradient. And the formula is y subscript 2, that's 2 to the bottom, subtract y subscript 1 over x subscript 2, subtract x subscript 1. So remember we labeled before, this is x1, y1, x2, y2. So let's substitute into our formula for the gradient. y2 is negative 4, subtract y1 is 10, over x2 is 4, subtract x1 is what? Negative 3. So put negative 3 in brackets. So we're going to get here negative 14 all over. A minus by minus is a plus. 4 plus 3 is 7. So the gradient is negative 2. Yeah? So the line is supposed to be sloping this way. Yeah? So I shall label it PQRS. Yeah? So you see the line going this way instead. Yeah? Because you have a negative gradient. But let us now find the equation of the line. So to find the equation of the line, what do? We need to find C. So to find C, you want to replace y, m, and x with numbers. Already we know we're going to replace m with negative 2. But where are the numbers coming from for y and x? Again, this line PR, we are finding the equation of. Right, 2 points down the line. 2 points. You just pick one of your points. So you know m is negative 2. Pick one of the points. You go with p. If you want to go with p, negative 3, 10. And I'm going to replace, this is x. That is y. I'm replacing y with 10. I'm replacing m with negative 2. I'm replacing x with negative 3 in brackets plus c. Yeah? So we're going to get what? This is 10 is equal to negative 2 by negative 3, which is positive 6 plus c. And what we're going to do is to subtract 6 from both sides. So we can get c by itself. So 10 minus 6 is equal to c. And c is equal to 4. So the equation of the line is y is equal to, replacing now your m, write it back in the form. I'm not going to stop here and say I'll form the equation. I'm also write it back in that form, replacing m and c with the numbers or values we got. So it's y is equal to negative 2x plus 4. And that's the equation of the line PR. Alright, let's move on to the next. Right, so looking at B, functions and relations again. With our revision review exercises, functions and relations. So let's look at B. So I'm erasing here. So looking at 4B. Two functions f and g are defined as follows. We have f of x is equal to 3x plus 1, and we have g of x is equal to x squared. Good? Find in its simplest form an expression for 1 f of x minus 2. So just a simple case of substituting or replacing this x here with this x minus 2, that's all. So just simply going to take this entire expression and replace x with that expression. So it becomes 3 in brackets x minus 2 plus 1. Yeah? And what we can do is to remove the brackets. 3 by x is 3x. 3 by negative 2 is negative 6 plus 1. We get 3x minus 5. And that's a representation for f of x minus 2 in brackets. Let's look at part 2. We have to write an expression for g of 3x plus 2 in brackets plus 10. Okay? So first let's find g of 3x plus 2. Again, the same as what we did with f of x minus 2. I'm going to take this gx plus 2 here, and I'm going to replace that x with 3x plus 2. So it's going to be 3x plus 2 in brackets squared plus 10. Alright, so g of 3x plus 2, let me write g of 3x plus 2 first, is equal to that. And therefore, g of 3x plus 2 plus 10 can be now written as 3x plus 2 in brackets squared plus 10. Yeah? And what we can do is, if we want to simplify, we can simplify. 3x plus 2 squared is 3x plus 2 multiplied by 3x plus 2 plus 10. So let's expand it so to simplify the expression much further. So to expand 3x plus 2 squared is 3x plus 2 by 3x plus 2, 3x by 3x, 3x by positive 2, 2 by 3x, 2 by 2, and therefore we're going to get 3x by 3x is 9x squared, 3x by plus 2 is plus 6x, 2 by 3x is plus 6x, 2 by 2 is 4 plus 10, which will simplify to become what? 9x squared plus 12x plus 14. And that is for g of 3x plus 2 plus 10. Alright, let's see next part of the discussion. So moving on to question 5. So this is a stats question, right? So question 5. So right, Mr. Morgan administers a spelling test in his class. The table below shows the number of words out of 10 that each student spelled correctly. So you have number of words, and you have course, the number of students who spell them correctly, right? Yeah? So this is telling us here, 8 students spell 5 words correctly, 4 students, 6, 2, 7, and so on, right? So they want us to what? For the data set shown above, state A the mode. So what is the mode? So part 5A, part 1. Right? So 1A. So the mode, when data is on a table, and especially when you have single values to represent your what you're observing, and what your observations are, those single values, that is called ungrouped data. And when you have to find the mode for ungrouped data, when you take raw data and arrange it on a table, right? Then the mode is always the observation. These are the observations here corresponding to the highest frequency. So the highest frequency here is what? The highest frequency is 8. So what observation corresponds to 8? 5. So you know that your mode is 5. Observation corresponding to the highest frequency. So that's it for part 1A. Let's look at part 1B. Right, so they want us to find here the median. So we're going to find the median. Now, when you're dealing with stats and you ask to find the median, what normally comes into play to help you will be something called the cumulative frequency. So cumulative frequency will normally come into play to help you to find the median. Alright? So, how are we going to treat with this? Now, we have this data, this table represented as a horizontal table, right? So, to help or to make it much easier, let's convert this horizontal table into a vertical table. So, I'll have here, so this is part B. So, I'll have number of words. I'll have frequency. So the number of words is normally, which will be observations, denoted by X, frequency F. So the number of words here are 5, 6, 7, 8, 9, 10. And the frequency you have 8 corresponds to 5, 4, 6, 2, 7, 2, 8, 3, 9, 4, 10, right? So we want to determine what's the median for this data, ungrouped data. So we're going to create another column which will be called the cumulative frequency, and that will be used to help us to find the median. So what's the cumulative frequency? So it's also called the running total. That will allow your data to be organized in ascending order. So you start off with 8. Always on the frequency column, start off with 8. 8 plus 4 will give you 12. 12 plus 2 will give you 14. 14 plus 2, 16. 16 plus 3, 19. 19 plus 4, 23. Alright? So this is a cumulative frequency column, and now we're going to use that column to help us determine what is the median. So to get the median, we're first going to locate the position of the median, where the median lies, right? So the position of the median will be found by using an important formula, which is a half times n plus 1. And n is your total frequency. Yeah, add up all these numbers in the frequency column, you're going to get that 23. That 23 there is the total frequency. That's the highest value or the highest frequency, highest value or the total frequency here, right? So it's the total frequency, I should say. So what I'm going to do, this is n. This is a half times, I'm going to replace this n with 23 plus 1, which will give me a half times 24. So this here is my 12th position. 12th position. Now where's the 12th position? So I'm using the cumulative frequency to help me to identify the 12th position. And the 12th position is here on the cumulative frequency column of that table, that frequency table. And the 12th position corresponds to what? The 12th position corresponds to how many words? Right? 6 words. So the median, when they ask us for, right, the median number of words, that's basically the median number. When they ask the median, it's the median number of words. The median number of words will be equal to, so the median will be 6 words. Right? The mode will be, you can put 5 words. So make sure you state what it is, the mode, 5 words, and the median will be 6 words. And now they want us to determine part 2, calculate the mean number of words spelled correctly. What's the mean number of words spelled correctly? Right? So, well, this is 5 words, you should put spelled correctly. This is the median number of words, 6 words spelled correctly. So let's get the mean number of words spelled correctly. So to find the mean, of course you have to know this important formula now. X bar represents the mean, and to find the mean we use the summation symbol. That means it's sum of. So it's the sum of, there's a formula to find the mean. It's the sum of fx all over the sum of f. So the sum of fx. Good? So I'm going to use the same table I have here, tell me to find the sum of fx. So this is f, this is x. I'm going to create another column, mark fx. Good? So let me find fx. So that's x by f, so 5 by 8, which is 40. 6 by 4, 24. 7 by 2, 14. 8 by 2, 16. 9 by 3, 27, 10 by 4, 40. So from that now, I can find the sum of fx. Let me find the sum of fx. So let me add up everything in that fx column. So that will be what? 40 plus 24 plus 14 plus 16 plus 27 plus 40, 161. Right? That's the sum of fx. And what's the sum of f? So go to a frequency column now. So this will be the sum of f here. So we get the sum of f. So the sum of f, we know we add up all those. We're supposed to get 23, right? So on the cumulative frequency, this is the total frequency. Add up all those numbers, just prove it. 4 plus 8, plus 4 plus 2 plus 2 plus 3 plus 4. Yeah, 23. So that's the mean. The mean, which is represented by the symbol x bar, is the sum of fx, which is 161 all over 23. What's 161 divided by 23? You get 7. Right? So the mean number of words spelled, or the mean words spelled correctly will be 7. Alright? So that's how you find the mean there. Alright, so let's move on to the next. Right, so you have our cumulative frequency curve. So let's look at this. So, cumulative frequency curve, another name for it, they call it the OGIVE, O-G-I-V-E, right? Some people say OGIVE, some people say OGIVE, right? So, And they bring that into multiple choice, right? So look out for that. Another name for the cumulative frequency curve. Or guy will give. I will give. Now, it says here looking at B, and this is what? This is 5-part 2 but 5-part B, right? So it says here, the attendance officers at a particular school recorded the time in minutes taken by each student in a group to travel to school. The data collected is shown on the cumulative frequency curve below. So you have this cumulative frequency curve here, right? And you have this data, and what they want us to do is, from that data, using a cumulative frequency curve, find an estimate for the number of students who took at most 32 minutes to travel to school. So you want to determine the number of students who took at most 32 minutes to travel to school. Yeah? So how are we going to do that? So this cumulative frequency here came from the frequency axis. And frequency in this case will represent number of students. Since cumulative frequency represents number of students. And of course you have the time axis. So you want to move from x to y, from time to cumulative frequency, or from time to number of students. So this axis here also represents number of students. Good? So cumulative frequency also represents number of students. So the question asks us, the number of students who took at most 32 minutes to travel, at most 32 minutes. So you're not going beyond 32 minutes, so at most. So let's see how many students. You look at you find 32 on the time axis. So again, it's always good to know what one subdivision is equal to, because it's going to help you to find, values on the axis. So, you have 5 subdivisions. You have 5 of those tiny boxes. 1, 2, 3, 4, 5. So 5 boxes is equal to 10. So one box will be 10 over 5, which is 2. So every box will be 2 units. So if you want 32, if this is 30, the box after 30, this is the box or division after 30, subdivision after 30, this is 32 here. Good? So having found 32, let us now determine what it corresponds to on the cumulative frequency of number of students active. So this is where you're going to move from x to y, call that extrapolated. So moving from x to y. So what we're going to do is draw a dotted line up. Oops, yes sir. Let's get it back in focus. Right. So you're going to draw. Yes, I'll have to do some adjusting here. T-square accidentally hit the projector. So let me just quickly make an adjustment here. Alright, good. Yeah? We're back in the heater things. So this will be what? So we have to find 32, so this is 32 here. And what we want to do is to move from the time axis to the student axis. So we're going to draw a line up from here. To meet the curve, and then we're going to draw a line from the curve to the student axis. Alright? So, let's determine what that is equal to. So, where does it cut the cumulative frequency on the student axis? Alright? So, again, it's always good to know what. So, this is your x axis, this is your time axis, right? So, this is time. So, let's look at the number of student axis now. Number of students. So, note if 5 boxes is equal to 20 units on the y-axis, then what one box is equal to? So 5 boxes is equal to 20. One box will be 20 over 5. So that will be what? 4 units. Good? So this is 40. This will be 44. This will be 48. And this is what? 52. That falls exactly on 52. So this is 40, 44, 48, this is 52 here. Yeah? This will be 52, and this will be 56, and this will be 60. So that falls exactly on 52. So we can say here, question asked, the number of students who took at most 32 minutes to travel to school. So state here, 32 minutes, number of students who took 32 minutes equal 52 students. Good? So 52 students. And let's see what the next part of the question asks us. What's the interquartile range? So part 2, interquartile range. So you find interquartile range from your graph, right? So interquartile range, so looking at, this was 5b part 1. Let's look at 5b part 2. So 5b part 1. Now 5b part 2. So we want the interquartile range. So we're going to get the interquartile range. So, the interquartile range, which we normally denote by IQR, is equal to the upper quartile minus the lower quartile. So, upper quartile, which we denote by Q3, subtract the lower quartile, which we denote by Q1. Good? So to get the, let's get the upper quartile first. So to get the upper quartile, let's get the position of Q3. And the position of Q3 is 3/4 times n. Alright? And of course, n will be the highest value on your cumulative frequency axis. Right? So this is where the graph, right? That's where it ends. Of course, it corresponds to 220 on the cumulative frequency axis. Right? So this is n, 220. So we're going to find 3/4 of 220. 3/4 of 220 will give us what? 3/4 by 220, that'll be 165. So we're looking at the one, as a position, the 165th position. And the 165th position will correspond to what on the time axis for us to determine what is the upper quartile. So what is Q3? So let's get 165, the position, 165th position. So remember this is what? 160, so the box after 160, that's 164. Good? If that's 164, the box after that would be 168, right? So 160, 165, this will be 168 here. This is 164. And this is 168. So you know that this is 168 here. So 165 has to lie between, right? Just approximated between 164 and 168. 165 will lie somewhere there. Right? So what we're going to do is draw a dotted line across to draw that line across to touch a curve. Right? So reach a curve there. And then we want to travel down to the time axis. This will be what? Right, so that's a time axis there. So this looking like about what? There's 50, 52, or 54. Yeah, that look like about 54 there. So therefore the upper quartile will be 54. So that's the upper quartile. Now let's get the lower quartile, Q1. So let's get the position of Q1. That's a quarter times n. Right? So you know n is 220. We're going to find a quarter times 220. So a quarter times 220. That's 55. Which is the 55th position. Yeah? So let's go find that on the cumulative frequency axis, and we do the same. We draw a line across, touch, and then we travel along to the time axis. Good? Yeah? So I'll put here as this is Q3 here. Good? So let's get Q1. So let's find 55. So you know if this is 40, 44, 48, 52, this is 56 here, this is 56, you know 55 will be just before 56, so I'll put 55 somewhere around here, right? Right, so 55 just before 56, which is there. And I'll draw my dotted line down, right? So I'll draw it here. Right. So I meet somewhere around here. And that looks like about what? That's 30, 32, you have 34. So halfway between 32 and 34, that's what? 33. Yeah? Yeah, so 33. So I'll put here as 33. So I look like it's about half, because this is 32 here. After 32, so we ascended by in units of 2, so 30, 32, 34, and that 4 is halfway between 32 and 34, so that's about 33. So I'll put Q1 is equal to 33. Good? So this is 33 here, which is Q1. So I'll put 33 here. And that's Q1, 33. Good? So the interquartile range, so this is the interquartile range, right? That's a range between the difference between Q1 and Q3. So the interquartile range, so IQR. So therefore IQR is Q3, which is 54. Subtract Q1, which is 33, so you get 21 as the interquartile range. So the interquartile range there will be 21. Alright? So let's move on to the next. Right, so we have here a probability question. So let me erase all this. Right, so we're looking at, this is 5 A, B, C. So 5C. The letters in the word positivity are each written on separate cards and placed in a bag. Dacia picks 2 of these cards at random with replacement. So when you see the word with replacement, it normally relates to what you call independent events. And with independent events, we're dealing with an important rule called multiplication rule. Yeah? So when you're dealing with replacement, independent events and multiplication rule. So independent events right equal multiplication rule. Good? So it says here, find the probability that she picks the letter I, then the letter V. So the probability that she picked the letter I, so first you have to know what is probability. Probability, so P, that she picks I, picks the letter I, will be what? So probability is the number of ways an event can occur. So the event is what you're investigating all over the total number of possible ways. Right? So that's probability. So the number of ways an event can occur over the total number of possible ways. So the number of ways, so they ask find the probability that she picks the letter I. Probability that she picks the letter I. How many ways she can pick the letter I? We have 1, 2, 3 ways. That's the number of ways. 3. All over the what? total number of possible ways, the total number of letters we have in positivity here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 3 out of 10. Right? The probability of picking an I. And then the letter V. Right? So letter V. So probability that she picks letter V. So what's the probability that she picks letter V? The number of ways we can pick the letter V will be what? One way, because we only have one V. Over the total number of possible ways, which is 10. So find the probability that she picks the letter I, then the letter V. Right? Again, we deal with independent events because we talk about with replacement. So therefore, we know the multiplication rule will come into play. So therefore, the probability, so I'm going to put here P, that she picks letter I, then letter V will be to multiply the probability of picking an I by the probability of picking a V. So you get 3 all over 100. That's the answer for part C. Alright? So let's move on to the next. Right, so question 6. Right, so question 6, we have 4 more, so 6. So So 6. So the asker said, of course, this is a solid, and they call this a prism. So a prism is a solid. We have the same shape, which is the cross section here. So if I cut this up into different pieces, I'll see this face. Every time I cut that into pieces, I'm going to see that face, which is known as my cross section. And this shape here is more or less a trapezium. Alright, so that's a prism. So they told us take pi as 22 over 7. The diagram below shows a gold bar in the shape of a trapezoidal prism. Right, so it's a prism. A trapezoidal because the cross section is a prism. Its volume is 2,886 cm3. The length and height of the prism are indicated on the diagrams. Every length and every height indicated on the diagram. Calculate the area of the shaded cross section of the trapezoidal prism. So they want us to find the area of the shaded cross section, right? See, cross section as the proper name of it. So note, you have to make sure when it comes to a prism, you know what's the volume of the general formula for the volume of a prism. So volume of a prism is equal to the area of a cross section times the length of the prism. Good? And they want us to find the area of the shaded cross section. So you want to find the area of the cross section. And they gave you the volume and we know the length of the prism. So the volume of the prism is 2,886. The area of the cross section, let's call it x. You want to find x. Good? And the length is 31.2 centimeters. So therefore, to get the area of the cross section, what I have to do is to make x a subject, so I'm going to divide both sides by 31.2. Whatever to one side, I do to the other. Right? So let me divide 231.2 cancel out, I get x by itself. And that is 2,886 divided by 31.2. So I'm supposed to get here the area of the cross section as 92.5 cm squared, right? Because it's area of the shaded cross section. Yeah. So that will be the area of the cross section. So let's look at now next part of this question. So part 2, the cuboid shaped gold bar shown below, so that's a cuboid, also a prism, has the same volume as a trapezoidal prism shaped gold bar displayed at A. So it has the same volume. Calculate the height of the cuboidal shaped gold bar. Alright? So all you want to do is to find the height of that gold bar. So if this cuboidal gold bar has the same volume as the trapezoidal prism, then how are we going to determine what's the height? So we know this is part 2, 6 part 1, 6 part 2. Yeah? So we can say here that the volume of cuboid, yeah, and the volume of the cuboid we know is length by width by height. Yeah, so a cuboid is going to be length by width by height. Yeah, and if the volume of the cuboid is the same as the volume of the trapezoidal prism, which is 2,886, and we have the length of that cuboid, which is 30.6, we have the width of that cuboid, which is 8.2, we can determine what is the height. So this is 2,886 is equal to 30.6 by 8.2, which will give us 250.92 times the height. And let's make the height the subject now, so dividing both sides by 250.92. What I do to one side, I do to the other. So when those two divide into each other, you're going to get the height as 2,886 divided by 250.92. Right, so the height there will be 11.5 centimeters. So that's the height of the cuboid prism gold bar, right? Now, let's look at part B. So, the trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. Calculate for each sphere of gold its radius. Okay? So the trapezoidal gold bar is melted down and all the gold is used to make 6 identical spheres. So 6 identical spheres. Right? So you have 6 identical spheres. 1, 2, 3, 4, 5, 6. Good? They want us to calculate for each sphere of gold its radius. Okay? And they gave us what's the volume of a sphere. So one of these spheres, this is the volume of your sphere. Alright? Now, so that trapezoidal gold bar is melted out to make 6 of those, and we know the volume of the trapezoidal gold bar, then we can find the volume of each of those gold spheres. Yeah? So, I'll erase here, and we're going to state so this is 6B. We're going to say the volume of a gold, so this is 6B part 1. So the volume of a gold sphere will be to take the volume we have of the trapezoidal prism 2886 and we're going to divide it by 6. Right? So 2886, I want to make sure it's 2886. 2886 divided by 6. So that will give us 2886 divided by 6. Right, so 481. 481, and the unit will be, right, cm cube. Will be the volume of one of those spherical gold bars, gold spheres, sorry. So what we want to do is determine what is the radius of each one of these spheres. Yeah? So to determine the radius, see now we know what's the volume of one, and we know what's the volume, the formula for the volume of a sphere, we can determine what's the radius of one of those spheres. So therefore, using the formula, volume of a sphere is 4/3 pi r cubed. So the volume of one sphere, the people of one gold sphere is 481, and that is equal to 4/3 times pi 22/7 times r cubed, which is the same as 481 is equal to 88/21 times r cubed. So to make r cubed, we simply have to divide both sides by 88/21. So these two will cancel out. I'm going to put on one side and I'll do together. So this is 481 divided by 88/21. So this will be 481 multiplied by 21/88 will be equal to r cubed. Let's work that out. That's 481 multiplied by 21 divided by 88. Alright, which will give us 114.78 is equal to r cubed. So that's represented to 2bp, and therefore we can determine what's the radius. So r now, to get r by itself, I have to remove that power of 3. And how do we remove a power of 3? We find the cube root of r cubed to give you r, and what you do to one side, you do to the other. So the cube root of r cubed will make that power of r by, that power of 3 by r disappear, so you get r by itself, and the cube root, so that's why the cube root, so the cube root of 114.78 will give us a radius of 4.8, I'll put it to two decimal places, 4.86 centimeters will be the radius of one of your gold spheres. Yeah? So let's move on to the next part. So the one is surface area of one of the gold spheres. So let's get the surface area of a sphere, right? With the radius r. So to get the surface area, let me make sure for the radius. So to get the surface area of one of the gold spheres, let me erase. So this is 6b part 2. So the surface area of one gold sphere is what? 4 pi r squared. And since I don't know what's the radius, let's work out the surface area. 4 by 22/7 by 4.86 squared. So that's what covers the surface area then. That is 4.86 by 4.86 by 22 over 7 by 4. Right, so the total surface area we should have the surface area, of one sphere, one gold sphere will be 296.93 centimeters squared, will be the surface area of one of the spheres using that formula there. Alright? Right. So the mass to the nearest kilograms, given that the density of gold is 19.3 grams per cm3. So, what is the mass? Good? So part 3. So we know density is mass over volume. Yeah, they gave us the density of gold, which is 19.3 grams per cm cube. We want to find the mass, and we have the volume. We got the volume previously of we got the volume previously to be, yes, let me just double check here what we got the volume to be. We got that volume to be, right, so we got the volume to be, I think it was 481, I believe it was 481, yes, I believe it was 481. Yeah? cm cube. So we have to determine the mass, good? So that mass will be right, so we have to determine mass. What we're going to do is we are going to cross multiply. We can multiply both sides by 481. So that's the only way we can remove this from the fraction. 1 times your mass is your mass. This is 19.3 multiplied by 481. And 19.3 by 481 will give us 9,283.3. And of course, when we work out this mass, it's going to be in grams. But remember, they told us what is the mass in the nearest kilogram, to the nearest kilogram. So this will be our mass in grams. So therefore, we have to determine the mass in kilograms. So mass in kilograms will be, so mass in kilograms will be to divide that mass by 1,000. Which will give us 9.2833 kilograms. Alright? So that will be the mass of your gold sphere in kilograms. Okay? Alright, so let's move on to the next. Right, so moving on to question 7. So looking at the pattern recognition questions. So 7, the diagram below shows the first 4 diagrams in a sequence of regular hexagons. Each regular hexagon is made using sticks of unit length. So made of sticks, right? So you have these regular hexagon shapes, good? Or shapes made of regular hexagons. So we have 1, 2, 3, 4. And if we look at the pattern, we start off with 3, and then we keep increasing. 2, then another 2, and then another 2. Yeah, so starting with 3, then we increase it 2, then 2 more, and then 2 more. Alright? So if you ask a fifth diagram, you know you're going to make sure you have 3 and you're going to increase by 2. So let's see. So they want us to complete the diagram below to represent diagram 5 in the sequence. So we know we must have our 3 and we must increase by 2. So this is 3, and how many 2's we have here? 2, 4, 6 2's. So we expect in this diagram we'll have our 3, 2, 4, 6, and we're increasing by 2 more, so that will be 8. So we're looking at here, I'm going to start off, let me make sure I have my 3. Good, so I see my 3 there, and I will have 2, 2, so 2, 2, 2, and how many 2's I want to make sure I have there? 2, 4, 6, 8, right? 2, 4, 6, and we put 2 more. Alright? So that's what we're going to have there. So that will be your shape for diagram 5. So this will be diagram 5. Good? So let's move on to the next part of this. So it says here part B. So the number of regular hexagons H, the number of sticks S, HS, and the perimeter of each figure P follow a pattern. So we have a pattern there. The values for H, S, and P for the first 4 diagrams are in the table below. So we have the values of H, S, and P for the first 4 diagrams are in the table below. Study the pattern of numbers in each row of the table and answer the following questions. And answer the questions that follow. Complete the rows marked 1, 2, and 3 in the table below. Okay, so we want to complete 1, 2, and 3. Alright, so they want us to complete the rows marked 1, 2, and 3. So you want to fill all these spaces here. Now with pattern recognition questions, what is always advisable is to determine what is the expression in terms of n. So you see under hexagons, once we obtain the expression in terms of n, it will help us to determine the number of hexagons. Similarly, an expression in terms of n for the number of sticks, and also an expression in terms of n for the perimeter. Now, with the pattern recognition questions, these numbers are sometimes, they normally follow a particular sequence, right? Sequence of numbers. So we have 3, 5, 7, 9, and if we have here, let's start with number of hexagons. Right, each. You have 3, 5, 7, 9. Good? Now if you look, moving from 3 to 5, 5 to 7, 7 to 9. And we're doing so by adding Yeah? So you're adding 2. Good? And that constant 2 is consistent throughout. Now, with this type of sequence of numbers here, it's called an arithmetic sequence of numbers. An arithmetic sequence of numbers. And for the arithmetic sequence of numbers, there's an important formula we need to know. So this is an arithmetic sequence of numbers. And there's a formula you need to know for the arithmetic sequence of numbers. It's A plus n minus 1d. Good? A in your sequence will be your first term. So A is the first term. And D here is the common difference. So the first term is automatically what? 3. A is equal to 3. D, it's called the common difference. Alright? And the common difference here will be 2. Right? And it's always an arithmetic sequence. When the common difference, you you're always adding that constant from the previous term to the present term. So from the previous to present, you keep adding that constant throughout. So once you keep adding that constant, then it is the common difference, and therefore that type of series is known as an arithmetic. That type of sequence of numbers will be known as an arithmetic sequence of numbers. So if they want us to write an expression in terms of n for the number of hexagons, you want it in terms of n, all you're going to do is replace A with your first term, which is 3. So we're looking at number of hexagons, H. So replacing the first term with 3 plus n minus 1, we replace the common difference with what? 2. And then multiplying 2 by this n minus 1. So we're going to get 3 plus, let me remove my brackets, 2 by n is 2n. And 2 by negative 1 is negative 2. Yeah? And we can say 3 subtract 2. This is 2n plus 1. 3 subtract 2 will give us positive 1. So the expression for the number of hexagons in terms of n will be 2n plus 1. So I can replace that with 2n plus 1. And let's check it out. If I replace n with 1, 2 by 1 is 2 plus 1 will give me 3. If I replace n with 2, 2 by 2 is 4 plus 1 is 5. Replace n with 3. 3 by 2 is 6 plus 1 is 7. Replace n with 4. 4 by 2 is 8 plus 1 will give me 9. So therefore, we have to determine for 5 is going to be what? It's going to be, of course, 5 by 2, which is 10 plus 1, which will give us 11. So that will be 11. Alright? Let's also check out the number of sticks, S. And let's see if it also follows an arithmetic sequence of numbers. So you have here number of sticks. And we have 15, 23, 31, 39. So remember, it only becomes arithmetic if that number that allows you to move from the previous to the present, right? You add that number from the to the previous to get the present. You must add that constant, and it must be consistent throughout. So let's see. So 15 to 23. So 15 plus 8 will give me 23. Yeah, so 15 plus 8. 23 plus 8 will give me what? 31. 31 plus 8 will give me 39. So clearly this follows an arithmetic sequence of numbers also for the number of sticks. Right? So number of sticks, number of hexagons, right? So we're going to number of sticks now. So we know for us to create our expression in terms of n for the number of sticks, our formula, this will be, we know A, the first term is 15. D, the common difference is 8. And let's use this formula. So let's be familiar with this formula. So using that formula, A plus n minus 1 in brackets D. So all I'm going to do is to replace A with 15 plus leave n as is, subtract 1 as is, and D, I'm replacing D with 8. That's 8 multiplied by n minus 1. So I'm going to write here 15. Let me remove my brackets. 8 by n will give me 8n. 8 by negative 1 gives me negative 8. And therefore I can say 15 subtract 8, which will give me 7. So this is 8n plus 7. Alright? So the expression in terms of n for the number of sticks S will be 8n plus 7. Right? We can check it out to make sure we're right. If I replace n with 1, 8 by 1 is 8 plus 7 will give me 15. Replace n with 2. 8 by 2 is 16 plus 7, 23. Replace n with 3. 8 by 3 is 24 plus 7 will give me 31. Replace n with 4. 8 by 4 is 32 plus 7, 39. Replace n with 5. 8 by 5 is 40 plus 7 will give me 47. Alright? And let me determine, so always with these questions, determine or find the expression for the, or whatever you're investigating, find that in terms of n first, then you can find everything else. So let's get for the perimeter. So let's look at the kind of sequence for the perimeter. So for the perimeter, we're looking at here, so I'll put perimeter, I'll write it here, perimeter. So we have the sequence of numbers 12, 16, 20, 24, 28. Good? So again, if we look, we see here where we're moving from 12 to 16 by doing what? By adding 4. From 16 to 20 by adding 4. 20 to 24 by adding 4. 24 to 28 by adding 4. So we know that we have our first term A will be 12 and the common difference D will be 4. Alright, so we must add that constant consistently for it to be an arithmetic sequence of numbers. And therefore, let's use our formula. A plus n minus 1D. So I'm replacing A with 12 and even the n minus 1 as is, and I'm replacing D with 4. So this will be 12, remove the brackets, 4 by n is 4n, 4 by negative 1 is negative 4. So I'm going to get 12 subtract 4 is 8, so 4n plus 8. So I know for my perimeter, the expression in terms of n will be 4n plus 8. And once I know what is my expression in terms of n, let's see if it corresponds. When n is 1, 4 by 1 is 4 plus 8 is 12. 4 by 2 is 8 plus 8, 16. 4 by 3 is 12 plus 8, 20. 4 by 4, 16 plus 8, 24. 4 by 5, 20 plus 8, 28. Good? So we completed that last row there by ensuring all expressions are in terms of n. Now let's fill the other spaces. So to determine the diagram number, first to determine what position will be our diagram. This is the first, second, third, fourth, fifth position. Right? Let's determine what position will be for a diagram with 47 hexagons, 191 sticks. Alright? And of course we also have to determine the perimeter. Yeah? So to find the diagram number, right? What we're going to do is simply just to find n. Right? So this will be your n. So to find that, this is what we're going to do. So let me erase. So to find n, this is what we're going to do. We're going to just simply create an equation, you know. You're going to say here 2n plus 1 is equal to 47. And I'm just going to work backwards to find n. So I'm going to say 2n plus 1 is equal to 47. 2n is equal to 47, subtract 1. 2n is equal to 46. And then I can divide both sides by 2. N is equal to 23. So the 23rd diagram will allow us to have 47 hexagons, 191 number of sticks. And we can also determine what is the perimeter, because once we know what n is, we can determine the perimeter. So we're just going to replace, so the perimeter for this will be, so the perimeter will be 4 times 23 plus 8, and of course 4 by 23 will give us 92, and 92 plus 8 will give us 100. Yeah? So this will be 100 here. So that there is your completed table. Okay, let's move on to the next. Right, so Skylar says that she can make one of these figures with a perimeter of exactly 1005. Explain why she is incorrect. Good? Why she is incorrect. Okay? So we're looking at part C. So why she is incorrect? Now we know that the perimeter, right, is equal to, and I erase the right, so the perimeter will be, let me just quickly, so this is 12, so this is a plus n minus 1d. So this is 12 plus n minus 1, d is 4, 12 plus 4n, subtract 4, 4n plus 8. So the perimeter is equal to 4n plus 8, right? Yeah? So that's the expression in terms of n for your perimeter. So it states here, Skylar says that she can make one of these figures with a perimeter of exactly 105. Yeah? So let's see. Let's see how many, let's see if the number of that shape is a whole number. If the number of that shape is a whole number, then it will satisfy the fact that she can make a shape with a perimeter of exactly 1005. If it is not a whole number, then it will prove that she is incorrect. Alright? So we know that the expression for the perimeter is 4n plus 8. And if that perimeter is 1005, let's determine if we can obtain a diagram, the number of that diagram. Let's see if it's a whole number. 4n is equal to 1005 and minus 8 from both sides. 4n is equal to 1005 subtract 8, which is equal to 997, and therefore I'm going to divide 997 by 4. So 997 divided by 4 will give us, right, we're going to get 249.25, which is not a whole number. Yeah? So therefore it will prove that she's incorrect. Yeah? Because this is the diagram number. So the diagram number, of course, cannot be a decimal number. It has to be a whole number. So that will prove that Skylar, make sure it's Skylar, that Skylar is incorrect. So therefore, since the diagram number is not whole, so since the diagram number is not a whole number, right, then scalar is incorrect. Good? So we got a whole number, but then certainly should be correct. Alright, so let's move on. Right, so we move on to part 2, right? So question 8. So we have 8, 9, 10, right? So right, so almost there. Question 8. So we have here now 8. Right, so getting some energy as we coming out to the end, right? Energy just swarming. So 8a, it says the functions f and g are defined as follows. Again, functions, we're going to brought functions twice, okay? F of x is equal to that, g of x is equal to that. Determine the value of g of 2. So we're looking at 8a part 1. So we have f of x is equal to 2x minus 1 over 3. G of x is equal to 5 minus x squared. So they want us to find 1a g of 2. So what is g of 2? Just simple case of substitution. So where I see x, I'm going to replace x with that 2. So this becomes 5 minus 2 in brackets squared. 5 subtract 2 squared is 4, and that will be 1. So that's g of 2. Let's simply replacing my x with 2. Next will be f inverse. So this is b. F inverse of 3. So we want to find the inverse of f, and then we're going to substitute 3. So we need to find f inverse of x first. And when you find f inverse of x, then you can substitute 3. You want to get an expression for f inverse of x, then you can substitute 3 into that expression. So how do we find the inverse of a function? So this is f of x, so we let, and again, we looked at functions within our review sessions. Let y, replacing f of x with y, let y be equal to 2x minus 1 over 3. And we'll interchange x and y. So where I see y, I'm going to put x. Where I see x, I'm going to put y. And then my final step is to make y the subject of the formula. So how am I going to make y the subject of the formula? So to make y the subject of the formula, what are we going to do? You never solve an equation with fractions, so the aim is to remove the fraction. So I'm going to put, I have two fractions here, x over 1 and 2y minus 1 over 3. When I have single fractions on either side, one fraction on the left, one fraction on the right, to remove the fraction, this is what I'm going to do. I'm going to cross multiply. So when I cross multiply, look what's going to happen. 1 by 2y minus 1 will give me 2y minus 1. X by 3 will give me 3x. No more fractions. And what I'm going to do now is to make y the subject. So to make y the subject, I'm going to remove negative 1 by adding 1 to both sides. So it's going to be 2y is equal to 3x plus 1. And then I can make y stand alone by removing the 2 in front of y. So I divide 2y by 2, 3x plus 1 by 2. And when the 2 2's on the left divide into each other to give me 1, I'm left with y as a subject, which is 3x plus 1 over 2. And this here represents f inverse of x. And after I've found f inverse of x, then I can find f inverse of 3. So I'm just simply going to replace x with 3. So I'm going to get 3 times 3 brackets plus 1 over 2. 9 plus 1 over 2. 10 all over 2, which is 5. So that's f inverse of 3 there. Right, and then they ask us to derive an expression in its simplest form for f g of x. So let me look at that. Let me erase here. So to get f g of x, so to get f g of x, so this is 8. Let's make sure I number it correctly. Right, so this is 8b part 2. Yeah? So we want to find f g of x. Good? So let me just rewrite my two functions. And g of x is equal to 5 minus x squared. Good? So to find that combined function of f and g, combining those two together, I am always going to, so I highlight my g of x, I leave my function on the left as is, I leave f as is. I'm going to replace my g of x, which I've boxed off, with the expression 5 minus x squared. And now I need to find f of 5 minus x squared. So it means I'm going to take this entire expression 5 minus x squared I have inside of this bracket, and I'm going to replace the x in my f of x, that 2x minus 1 over 3, that x I see next to my 2x, I'm going to replace that x with 5 minus x squared. So this will become 2 open brackets 5, I'm replacing that x with 5 minus x squared. Of course, I make sure I put 5 minus x squared in brackets, subtract 1 all over 3. Yeah? And of course, I am going to remove my brackets and simplify where I can, because they ask in its simplest form. So this is 2 by 5 is 10. 2 by negative x squared is negative 2x squared, subtract 1 all over 3. And therefore I can simplify my numerator. I can say 10 subtract 1 is 9 minus 2x squared all over 3. And if you want, you can leave it like that, or you can separate it 9 all over 3 minus 2x squared all over 3, which becomes 3 minus 2/3 x squared. Alright? So 3 to 9 is 3, and you have negative 2x squared over 3 is the same as negative 2/3 x squared. Alright? And that is your expression for f g of x. Okay? Alright? So, they want us to sketch the graph of the function g of x in the space provided below. On your sketch, indicate the maximum or minimum point and the roots of the function. Alright? So we have to sketch. And I think when we were doing our revision sessions, we looked at sketching. And let's see what g is a quadratic function. You have to sketch that. So that's a quadratic function, 5 minus x. So once you see variable squared, it's quadratic. So how are we going to sketch that? So we're looking at part 3. So looking at AB part 3. So you want to sketch g of x is equal to 5 minus x squared. Okay? So that there is a quadratic function because you have variable squared. So we know when we sketch that, our shape curve, our drawing will be that of a parabola. So it's either going to be this way or that way. So it's going to be a parabola. How do we know which one we are going to, our function will represent? When we look at the number in front of x squared, if the number in front of x squared is a negative number, then it will tell us that our curve is concave down. So it's going to be like this. So you're going to have a maximum turning point. If the number in front of x squared is positive, then the curve will look like this, which is concave up, and you have a minimum turning point. So in sketching this function, we need to find a few things. We need to find roots, one root. You need to find 2, your y-intercept. You also need to get your turning point. And you have to know the shape of the curve, right? And of course, 4, shape of curve. Alright, we know because the number in front of x squared is negative, we know the shape of the curve will be like that. Okay? So let's get the roots. Because the state here on your sketch indicate the maximum or minimum point. You have to get the turning point, right? And the roots of the function. So the roots will be known as your x-intercepts. So that's where your curve will cut your x-axis. This is the x-axis here. So the curve must cut the x-axis. And it's quadratic, so it's going to be at 2 points. So how we get the roots? We get the roots by, so 1, the roots, we let the quadratic expression 5 minus x squared be equal to 0. And what we are going to do now is to get our 2 values of x. Let's solve that quadratic equation. So to solve this quadratic equation is going to be easy. We can't factorize this, so we have no choice but to remove positive 5. This will be negative x squared stays on the left. Positive 5 will come across to the right as negative 5. I can remove my negative signs in front of x squared and 5 by simply, well, you can do it this way. Negative 1 is understood in front of x squared. So to remove that negative 1, that's negative 1 multiplied by x squared. So the opposite of multiplication is division. So I divide what is on the left by negative 1, and I divide negative 5 by negative 1. So my 2 negative 1s will divide into each other to give me 1. I'm left with x squared, and negative 5 divided by negative 1 is positive 5. And therefore, to get x by itself, I'm going to find the square root of 5. Remember, to get x by itself, I have to remove the power of 2. So I must find the square root of x squared. And what I do to one side, I will do to the other. I find the square root of 5. So once I place the square root symbol above x squared, it becomes x. And of course, that becomes the square root of 5. But it is important for us to put. Now, when you have been trained to always, when you find the square root of a number, to consider the positive result. But when you find the square root of a number, you can get a negative result as well. So this is the reason why we put a plus or minus sign in front of the square root symbol. Because when you find the square root of a number, you also get a negative result, which we often ignore. We just focus on the positive. So therefore, the roots here will be x is equal to plus or minus, and I write it as a decimal number. The square root of 5 is equal to, I'll put 2.2, so 1 decimal place. So plus or minus 2.2. So that will be my roots. Now, the y-intercept So the y-intercept is always, when you have a quadratic expression, for example, if you have ax squared plus bx plus c, the y-intercept is always c, the constant. So the y-intercept in this case will be 5. Because if you want, you can rewrite this as, instead of writing it as 5 minus x squared, it's the same as negative x squared plus 5. You can switch it around, let's put in negative x squared in front and 5 after. So you see where clearly the number in front of x squared is negative. and the constant C will be your 5. So you know that your curve will cut the y-axis at 5. Good? So C will be equal to 5 as the y-intercept. It's going to cut the y-axis at 5. Good? What we also need is the turning point. So we're looking at 3. Your turning point. So where the curve turns. Now normally you get a turning point when you complete the square. But we're not going to complete the square here with that expression. What we're going to use is a simple formula to find the coordinates of the turning point. So the x coordinate of the turning point, we're going to use this formula. So you can use this formula to get the x coordinate of the turning point. It is minus b all over 2a. Right? Minus b all over 2a can help you to get the x coordinate of the turning point. So, if we have this quadratic expression, and I'll write it as y is equal to minus x squared plus 5. Good? That's a quadratic expression, quadratic function. Note, a is a number, a is your number in front of x squared, which is negative 1. B is always a number in front of x, but we have no x here, so b is what? 0. And c, the constant, is 5. Alright? So let me substitute for b and a so I can determine what is x. So this will be negative, I'm replacing b with 0 over 2 times I'm replacing a with negative 1. So I'm going to get 0 over negative 2, which is 0. So the x coordinate of my turning point is 0. And once I know what is the x coordinate, I can find the y coordinate of the turning point. Remember, g of x and y are the same, right? So I can replace the g of x with y. So I'm going to get the y coordinate of the turning point. Instead of writing g of x, I'm writing y is equal to, you can write negative x squared plus 5 or the 5 minus x squared. Both are the same. So if you want to go with 5 minus x squared, no problem. So if I replace x with 0, my y coordinate will be 5 minus 0 squared. 0 squared is 0, 5 minus 0 is 5. So the coordinates of my turning point will be x is 0 and y is 5. So that's where my curve will turn. Alright? And the shape of my curve, so the fourth thing will be one that is concave down. So I have all that I need. I have my roots, 2 values of x, I have my y-intercept, and I know where the curve turns, and I know the shape of my curve. So let me now go sketch, now that I have all the information I need. So in sketching, this is your y-axis, this is your x-axis, and let me just draw and highlight it. So let me draw it again and highlight it. So that's your y-axis, and this is your x-axis. Oops, yeah. Right, so I have my y-axis and my x-axis, just to highlight it a bit more. So, this is the origin, this is 0. Yeah? This is 1, that's 2, that's 3, this is -1, -2, -3. So just a simple sketch. We just want to see these key pieces of information on our sketch. On my y-axis, I'll have 1, 2, 3, 4, 5. -1, -2, -3, and so on. So, my roots are, my two values of x are, so they are either x is equal to positive 2.2 or x is equal to negative 2.2. So those are the two values where my curve will cut the x-axis. So my curve will cut the x-axis at positive 2.2. I have 5 subdivisions, 5 tiny boxes between 0 and 1. So you know if there are 5 boxes making 1 unit, one box will be 1 over 5, which is 0.2. So every little box here is 0.2. So if this is 2, this here after will be what? 2.2. So I have 2.2 here. And if this is negative, so the other root or x-intercept, where the curve cuts the x-axis, will be negative 2.2. So if this is negative 2, then this here will be negative 2.2. So our curve will be passing through those 2 points. The y-intercept is where the curve will cut the y-axis here. The turning point is 0.5. So the y-intercept and the turning point is the same thing here. And the shape of the curve is a curve that is concave down. So this is what we're looking at. So when we sketch, that is what we're looking at. That is a sketch of our function g of x equal to 5 minus x squared. So this is g of x is equal to 5 minus x squared. That's what that is equal to. Alright, so let's move on to the next. Alright, so let me erase here. So looking at part B, this is 8 part B 2. So looking at 8 part But 8 part B, good? So the graph below shows a quadratic function. So on the grid above, so we have a quadratic function which is in the shape of a parabola which we just saw. And they want us to, on the grid above, draw the tangent to the curve at x equal to 1. So at x equal to 1, they want us to draw a tangent to the curve. X equal to 1. Right? So this is 1 here. Alright, so that's 1. So on the grid above, draw the tangent. So a tangent is a line drawn to touch or meet the curve at a given point, called the point of tangency. So at x equal to 1, so this is where the tangent must meet your curve. See that point as a point of tangency there. So you want to draw a line, a tangent, passing through that point. So let's see, I'm touching the curve. So that's what we're looking at. Good? So that's a tangent. That's a tangent. The line drawn to meet your curve at a given point, which is called a point of tangency. And that there is your tangent. So on the grid above, draw the tangent to the curve. That's it there. Right? Now, next part. Use a tangent drawn to estimate the gradient of the curve at x equal to 1. So they want us to find the gradient of that curve using the tangent, right? So to find the gradient, you can also use the fact we can draw a right angle triangle using your tangent to draw that right angle triangle. And of course, from there we can use our formula for gradient. You know the gradient of a line. So the gradient of tangent. So we find the gradient of the tangent first. The question asks us to find what? Right, I want to say estimate the gradient of the tangent at x equal to 1. So to find the gradient, this is basically what you're going to do. If you have a sloping line, you must create a right angle triangle. Using the tangent as a sloping line, of course, you're creating a right angle triangle. This is x1, x2, y1, y2. And we know the formula for the gradient is y2 minus y1 over x2 minus x1. So all we want to do is to use your tangent and create that right angle triangle. So let me create a right angle triangle. So I will say, just to make it easy, I'll use, because the tangent meets the y-axis, one time at -2, I'll put this as one of my points. Because remember, to find the gradient, you must have the coordinates of 2 points. So I'll let that be 1 point, and I'll let the point where the tangent meets the curve, which is known as your point of tangency, I'll let that be another point. Alright? So you have the coordinates of this point, which is 0, -2, that's the coordinates of that point. And I have the coordinates of this point where the tangent meets the curve, that is 1, 3. 1 on the x, 3 on the y. Good? So what I'm going to do is to create my right angle triangle between those 2 points, which in turn will help me to find my gradient, right? So this is so set up in the right angle triangle. And if you're doing sciences, you'll know that to find the gradient of a line, we have to set up that right angle triangle. So that is my right angle triangle. Alright? So let me find the gradient. So the gradient will be what? So the gradient of that tangent. So gradient of tangent. So I'm using the 2 points. 0, -2, 1, 3. And I'm using my formula for the gradient. M is equal to y2, y subscript 2, subtract y subscript 1 over x subscript 2, subtract x subscript 1. Let me label, this is x1, y1, x2, y2, and let me substitute into my formula for the gradient. M is equal to y2, which is 3, subtract y1, which is negative 2 in brackets, over x2, which is 1, subtract x1 is 0. So I'm going to get a minus by minus is a plus, 3 plus 2, 1 minus 0, 5 over 1, my gradient is 5. So simple, so that's the gradient there. So the gradient is 5. So use the tangent drawn to estimate the gradient of the curve at y at x equal to 1. Right? So the gradient there we put it as 5. Good? And then they ask us, write down the equation of the tangent in the form y equal to mx plus c. So this is part 2 here. And part 3, so the equation of the tangent, so looking at this part here now, the equation of the tangent is, of course, y is equal to mx plus c. It's a straight sloping line. We know our gradient is 5, and automatically we know the y-intercept. We know where this tangent cuts the y-axis. It cuts the y-axis at negative 2. So you know you can write your equation as y is equal to 5x minus 2. Alright, so that there will be the equation of the tangent. Alright, let's move on to right, so next question. This is right, that was question 9. This is 9 here, right? Right, so the 9 was left out. So this is question 9. Good? So you can have question 9 here. So let me erase. Right, so circle theorems. Topic that often gives students so many problems. Yeah? So your circle theorems. Or circle geometry as we sometimes see. Alright? So V, X, Y, and Z lie on the circumference as you see. So V, X, Y, and Z lie on the circumference of the circle shown below. Center O, we have center O is always the center, with diameter Vy, and UW is a tangent, as you see, UW is a tangent, a line drawn to make the circumference of the circle at V. Angle VXZ, VXZ is 62 degrees, and angle XVY, XVY is 80 degrees. Remember, it's always important to know where the angle is located. So the angle is always located. The letter in the middle will be your fixed point. So X is your fixed point, and of course, the two lines connecting to that fixed point will be is going to be Vx and XZ, right? Same thing for 18. V is your fixed point, and the two lines connecting at that fixed point V will be is going to be Vy and Vx to give you 80 degrees there, right? Right, so it says in this question, state a term that justifies the value of each of the following angles. Angle B, 62 degrees. So looking at 9A. So 9A, angle B, 62 degrees. Good? So we want to prove that this angle B here is 62 degrees. And to prove B is 62 degrees, what I'll do is pull out the term that is applicable to that. So I'll take it out from the diagram. So if I pull out from the diagram of my circle, I have ZV. Alright? And this is the term that will justify it. So this is a chord from Z to V. And what that chord does, that chord subtends or creates this angle at the circumference. A line drawn from Z, a line drawn from V, and they both meet at the circumference, which will be an X there, which is a 62, right? And that same chord will subtend and create another angle at the circumference, both in the same segment, because the chord divides the circle into two segments, major segment, minor segment. So in the major segment, this chord subtends or creates that angle at the circumference at X, which is 62, and the same chord subtends and creates another angle at the circumference, which is Y, and that will represent your B, which is equal to 62 degrees. So B will be equal to 62 degrees. Alright? So your justification for this will be state a term that justifies the values of the following angles. So B, so B is 62 because the reason will be the or angles in the same segment. So this is the segment here. Of course, the chord divides the circle into two segments. Angles in the same segment are equal at the circumference of the circle subtended. So subtend means to create. Subtended by the same chord. So the chord, same chord will subtend and create those two angles at the circumference in the same segment. Now, B. Proven angle C is 124 degrees. So I want to show angle C is 124. So let's pull out the angle of C. This angle C here, you want to show is 124. What you're going to use to justify that? This is what you're going to use to justify. You have a circle. Alright? Let me erase here. So C, 124, angle C. 124 degrees. How are we going to justify that? This is what we're going to use to justify. We're going to pull it out from the diagram. Circle. This is your chord from Z to V. Right? This is the center. Or in fact, I don't necessarily need to anyway. I don't need it. This is O, and this is X. So take all that from the diagram and I've placed it, put it up on the diagram, right? Now look what's happening here. To determine C, they're using this term. This arc length from Z to V, arc length, subtends or creates this angle at the center. See arc length? This is one end of your arc length Z, another end of your arc length V. A line is drawn from this arc length, from this point Z on the arc length to the center. A line is drawn from this point V on the arc length to the center, creating this angle. The same arc length from Z to V will also create or subtend, create this angle at the circumference, which is 62 degrees. And once that happens, once this arc length subtends or creates this angle at the center, and the same arc length subtends or creates that angle at the circumference, the angle at the center is always twice the angle at the circumference subtended by the same arc. So this angle is twice that one. So 62 by 2 will give me 124 degrees. So that angle is 124. So to justify, you're going to state here for B, 9B, we're going to state here the angle at the center of the circle is twice the angle at the circumference subtended by the same arc. And when we say subtended, it's a create, right? So subtended by or created by the same arc. Right? So that's why angle C is 124. Okay? Alright, let's see the other. Right, so angle OVW is equal to 90 degrees. Angle OVW. Where's angle OVW? So let me go back. Angle OVW. So look at OVW. Angle OVW. Alright, what term are we going to implement it? Let me erase here. So this is 9C. So angle OVW, want to show it's 90, right? So why is it 90? And I'm going to pull it out from the diagram so you can see. So if you look here, I'm going to take out from the diagram what we have in the diagram there, so you can see what angle OVW is equal to. This is my center, O, this is a radius, this is OV, this is a tangent. Good? This is U, V, and W. Good? And this is the toroid. So this is a radius. This is a tangent. So the term simply states the angle between the radius and the tangent at the point of tangency is always 90. So that is your reason for that being 90 degrees. So when they ask us to give the reason for angle OVW, it's simply the angle between the radius and the tangent at the point of tangency is 90 degrees. Good? That's it. So let's look at next. Right, find the values of the angles A, D, and E. Show all working where appropriate. So this is a show all working where appropriate to find angles A, D, and E. So let's go back to the diagram. So we want to find angles A, D, and E. Okay? So are we going to find A, D, and E? Now, to find A, we can use this. I'll pull out. So let me erase. So this is Right, 9C part 2. 9C part 2. Right, so let's get angle A first, angle A. So what I'm going to do is to pull out from the diagram the theorem so you will see what is applicable to us finding A. Right? So circle. This here is a chord, Z and V. This here is a tangent. Good? And there's an angle between your chord and your tangent, which is A. Alright? Now, the angle between the chord and the tangent, which is A, is always equal. This is the theorem. This is why you must be able to recognize the theorem. Is always equal to the angle the chord subtends at the circumference. So from Z to X and from, oh no, sorry. No, I'm doing the wrong thing here. Nope. So you can't use that to find A. Nope. Yep. I can't use that. Sorry. Right, so to find A, this is what we're going to do. Right, so this is what we're going to do to find A. So let me pull out the right thing now to find A. What I was going to do there is incorrect, right? So if this is center O, this is a radius, that is V, this is your tangent. So we pull it out what we're supposed to use to help us, right? Now, this here is Z. Right? Now, we know that this angle we got it before, and the center to be 124 degrees. Good? We also see here an important we also see here an important theorem. If you look here, the angle between the radius and the tangent at the point of tangent, see this entire angle here is 90. That is 90 degrees, okay? Let me make it a 90 degree angle. This is 90. Okay? So that's 90. Because this is your radius and this is your tangent. Okay? Now, we dealt with the fact that this triangle here, right, which is OVZ, this triangle here, is an isosceles triangle because from O to V, that is a radius, and O to Z, that's a radius. So that's an isosceles triangle. And therefore, if it's an isosceles triangle, the two base angles of this triangle are equal. So this here, this angle here, and this angle here, they are both equal. Yeah? So, to find A, this is what we're going to do. And you know, I could have used that because, oh gosh, I'll do both. So I'll show you how to find A. I'll do both. Right? So look at what's happening here. I can say here 124, 180 minus 124 is equal to 56, and 56 divided by 2 will give me 28 degrees. So this angle here, so one time we would have found D, because we have to find D. So this will be 28 degrees, and this is 28 degrees. So I'm going to show you two ways of getting A. So this angle here will be A. Right? So this is A here. So to find A, all I'm going to do, if this is 28 and this entire angle here is 90, all I'm going to do is to subtract 28 from 90, which will give me 62. So this is one way of finding A, using the fact that that is an isosceles triangle. This is 90 degrees, radius and tangent is 90, base angles are equal, so this is 28. 28 from 90 will give me 62, so I found A. Or I can use this, right? So I'll show two ways of getting the same answer, right? And it's what I was going to use before, all right? So you can say here as well, so let's identify, two ways. This is your chord. This is a tangent, right? This is angle A. So the angle between the chord and the tangent is equal to the angle that the chord subtends at the circumference to meet at B. B or Y, this is Y here, to meet at B. We got B to be 62 degrees. So this angle A will also be 62 degrees, because the angle between the chord and the tangent is equal to the angle the chord subtends at the circumference. So therefore we can use any one of the two to help us to find angle A. And I'll go with this one here because it's simpler, right? So angle A, so this is A is 62 degrees. Okay? Straightforward, because they didn't ask a reason, so there's no need to give the reason. So you state what is angle A equal to. Or we could have used this to help us to find it. Yeah? Now angle D. What is angle D equal to? Let's see angle D. Right, so we worked out angle D. We know angle D. This is angle D here, which is 28 degrees. Alright, and we got that because we know C is 124, and we know that this triangle is an isosceles triangle. So if it's isosceles, these two sides are equal, two base angles are equal. So I can say 180 subtract 124 divided by 2. 180 subtract 124 will give me 56 divided by 2, which is 28 degrees. So we know that angle D is 28 degrees. Alright? And now let's find angle E. To get angle E, what can I say for angle E? Right, so for angle E, I'm seeing here, and let me erase this so I can pull out from the diagram what I'm seeing. So angle E I'm seeing here, I have my circle, this is Z, that is V, and I have this big triangle here. Good? Now, this angle here, we can find that angle there. Remember, this is 28 degrees. So 28 plus 18 will give me this angle here. So 28 plus 18 will give me 46 degrees. This angle up here is what? 62. And this angle here will comprise of that angle there will comprise of that angle there will comprise of D and E, right? So that's the sum of D and E. So you know this is what? This angle here will be E plus D. Or E plus, and you know D is 28 degrees. So this angle, you know D is 28. Alright, and this is of course E. So you know that angle, this entire angle is E plus 28. So we have there a triangle, and you know that your aim is to find E. So you can create an equation to help you to find E. The sum of three angles of a triangle, three interior angles of a triangle is 180. So you can simply say that to find E, that will be equal to E plus 28 plus 62 degrees plus 46 degrees is equal to 180. So these three angles when added must give 180, and therefore this will be E 28 plus 62 plus 48 will give us 28 plus 62 plus 46 will give us plus 136 is equal to 180, and therefore E is equal to 180 subtract 136, and 180 subtract 136, right, that will be 44. So E will be equal to 44 degrees. So 28 plus 18 will give you 46, that's 62, and that angle there is E plus 28, and you know the sum of three angles of a triangle is 180. Create an equation, solve for E. Alright? So that's it for the circle term question. So let's move on to right, so you're almost there, almost to the end. Let's look at this question now, which will be so moving on to 9b, which is a question, again, we have practiced these questions in terms of the review sessions, looking at circle theorems, looking at questions involving bearings, sine, cosine rule, and so on, right? So they want us to, let's look at this question. So this is 9b. So 9b, they want us to calculate the length of QR. So we have to find the length of QR. So how are we going to find the length of QR? So QR is here. And what I'm going to do, I am going to pull it out. Let me draw the diagram. So let's draw the diagram. So this is P, S, R, Q. This is 72 degrees. This is 25. This is 16 meters, 18 meters, 43 degrees, 21 meters. So they want us to find the length of QR. So if we look, QR, this length, falls within this triangle QSR. And when we look at that triangle, what do we see automatically? Because we want to find QR, and opposite to QR, what do we see in that triangle? Two known sides and an included angle. Two known sides and an included angle. One time to help us to determine the length of QR, we're going to use the cosine rule. So using the cosine rule to help us to find the length of QR. And then using the cosine rule, what do? We label the sides first. If this is capital S, the side opposite capital S will be common S. If this is capital Q, the side opposite capital Q will be common Q. If this is capital R, the side opposite capital R is common R. So my cosine rule is this. And again, if you can't remember the cosine rule, look at the formula sheet, you'll see it. Because I want to find QR, which is common S, I'll start with common S squared is equal to common Q squared plus common R squared. Subtract 2 common Q multiplied by common R cos the angle at S. Alright, which is your included angle. We call that the included angle. So therefore, S squared will be common Q, which is 16 in bracket squared, plus common R, which is 18 in bracket squared, minus 2 times 16 times 18 cos the angle at S, which is 25 degrees. This will be S squared is equal to 16 by 16, which is 256, plus 18 by 18, which is 324, and this will be negative 2 by 16 by 18, that will give us negative 576. And let's find cos 25. So cos, they show calculators in degrees, cos 25, which is 0.9063. I had to take about 4 places after the point. So this will be S squared is equal to 256 plus 324, which is 580. Subtract 576 times 0.9063. Remember, you're not going to subtract 576 from 580. Remember, negative 576 times 0.9063. This is one term here. So you can't subtract 576 from 580. You have to multiply these two first, then subtract it from the 580. So this is S squared is equal to 580, and this will be, let's multiply by 0.9063. Right, so we have, this will be negative 522.0288. Let's subtract S squared is equal to 580, subtract 522.0288. You're going to get 57.9712. And therefore, to get S by itself, we have to move that power of 2. So we're going to find the square root of both sides. So S squared, we're going to find the square root of S squared, and what I do to one side, I must do to the other. I'm going to find the square root of 57.9712. So this will give me S. So the square root of S squared becomes S, and the square root of 57.9712 will give me 7.61. Good? And it didn't specify to approximate, so you can approximate to 1 decimal place if you want. So I'll put it to 1 decimal. So that will be QR is 7.6 meters to 1 decimal place. So that there will be the length of QR. Yeah? Using the cosine rule. Very important. Okay? Yeah? Alright, so let's move on to the next. So they want us to find the bearing of, so it says the bearing of P from S is 205 degrees. Determine the bearing of R from S. So the bearing of P from S is 205. So looking at the bearings part of this question here. Bearings. Good? So let's look at the bearings part of this question. So let's erase this information here so we can leave the diagram. Let's erase this information. So the bearing of P from S is 205 degrees. Determine the bearing of R from S. So the bearing of P from S. So P from S, so bearing is an angle, and what it does, it shows the position of one object relative to another. So the bearing of P from S. So where is P from S? So from S, I set up my north line. So the bearing must set up that north line. And of course, you're going to move in a clockwise direction from the north line. So that bearing of 205 degrees will be this here. Let me just make this smaller. So you're bearing of 205 starting from the north line and you're moving in clockwise direction. This is my bearing. It says here the bearing of P from S is 205. So this entire angle here is my bearing of 205 degrees. Good? Yeah? So that's P from S, so shown on the diagram. But then they want us now to determine the bearing of R from S. What's the bearing of R from S? So the bearing of R from S, so looking at part A, so you want to determine the bearing of R from S. So from S, I set up my north line, which I have, right? And I'm going to move in a clockwise direction from the north line to the line connecting R and S. So this is what I'm looking at here. So this is the bearing of R. Let me put it in a different color. You see this red marker which is showing clear enough. So this is so that there is the bearing of R from S. So that angle I need to find. And to find that will be pretty straightforward. If this entire angle here is 205 and I do this is 72 and that's 25, all I have to do is to find the sum of these two angles and subtract it from 205 to give me the bearing of R from S. So the bearing of R from S is simply equal to 205 subtract the sum of these two angles, 72 plus 25. So that's 205 subtract 72 plus 25 will give me 97, and 97 from 205 will give me 108 degrees. So that represents the bearing of R from S. And then they ask us for part B, the bearing of S from P. Bearing of S from P. S from P. So from P, I set up my knot, must have that knot line, and I'm going to move in a what? In a clockwise direction from the knot line to the line connecting P and S. Okay? That there is my bearing of S from P. So to find that angle, that bearing, what am I going to do? This entire bearing here is 205. That's 205. If I find this angle here, I'm dotting arc, because this is a full circle. So if I subtract 205 from 360 degrees, I'm able to get this angle here. Then I can implement an important angle for line being parallel to determine the bearing of S from P. So let me subtract 205. So 360 minus 205 will give me 155. So let me start by writing angle NSP or PSN. So this angle here, which is dotted, we dotted out. NSP, angle NSP will be 360 subtract 205. And 360 from 205 will give us 155 degrees. So this angle here is 155 degrees. And I have two knot lines. Look at it now. Look how easy I'm going to find this angle. Right? I have my two knot lines, so I know for lines being parallel, an important angle we saw earlier when we dealt with the question involving angles. When two lines are parallel, these two interior angles must add to give 180 degrees, called co-interior angles. So we're going to use co-interior angles now because these are two knot lines which are two parallel lines. So I'm going to find the bearing of S from P. So therefore, bearing of S from P will be 180 subtract 155, and 180 subtract 155 will give us what? 25 degrees, and it's for co-interior angles. Alright, so that bearing there will be 25 degrees S from P. Okay? Alright, so let's move on to the last question or last question. Last question. So let's erase. So question 10. So last question, question 10. Again, last question, most times you're going to see where they will bring a question involving your matrices. And of course, you see matrices, question 10. The determinant of the matrix 6, 2, v minus 5 and negative v is 24. And again, we did a question, something like this, similar to practice exercises. Calculate the value of v. So, we know the determinant. So, we have the determinant of our matrix. We know it is AD minus BC. And it says the determinant is 24. So the determinant will be equal to 24 because they want us to solve for an unknown quantity. So you must create an equation. And in that matrix, you know this is A, B, C, and D. Alright? So A, B, C, and D. Yeah? So we know A will be 6, D will be negative b, of course you place it in brackets, subtract b will be 2v, which I place in brackets, and c will be negative 5, which I place in brackets, is equal to 24. So let's work it out. 6 by negative b is negative 6v. I hold my subtraction sign. 2v by negative 10 is, then by negative 5, sorry, is negative 10v is equal to 24. So this becomes negative 6v, a minus by a minus is a plus 10v is equal to 24. Negative 6v plus 10v will be 4v is equal to 24, and therefore I can divide both sides by 4. 4v divided by 4, 24 divided by 4, v is equal to 6. So I've calculated or found my value for v. Alright, let's look at the next question. So, the matrices L and M are defined as follows. We have L, the matrix shown 2 by 2, M, the matrix shown at 2 by 1. Evaluate each of the following. The matrix product Lm. So let's find the matrix product Lm. So this is 10b. So 10b. So the matrix product Lm. So we set it up in the order which it is stated. L is 9, 5, 3, 2. M is 2, negative 4. And let's multiply those two matrices. Clearly, before you multiply two matrices, you make sure that they are compatible. You can multiply them. So check the order of the matrices. This is a 2 by 2 matrix. This is a 2 by 1 matrix. The two inner numbers are the same, which will indicate that we can multiply them. And the outer numbers will tell us the end result is 2 by 1. So the end result must look like this here. And how do we multiply two matrices? We take the rows of the first by the only column. Let me multiply. First row by my first column. 9 is linked to 2, so I'm multiplying 9 by 2 plus 5 is linked to negative 4, so I'm multiplying 5 by negative 4. Then my second row by my only column, 3 is linked to 2, so that's 3 by 2 plus 2 is linked to negative 4, so that's 2 by negative 4. When I simplify that, what am I going to get? 9 by 2 is 18 plus 5 by negative 4 is negative 20, which I place in brackets. 3 by 2 is 6 plus 2 by negative 4 is negative 8, which I place in brackets. And let me simplify that now. A plus by a minus is a minus. So 18 minus 20 will give me negative 2. And a plus by a minus is a minus. 6 minus 8 will give me negative 2. So that is what we should have gotten for the product of L and M. Those two matrices. Okay? Alright, let's move on to the next. So we want the inverse of the matrix L. The inverse of the matrix L. So let me erase. So to find the inverse, so we're looking at 9 B part, this will be part 2. So you want L inverse, the inverse of the matrix L. So of course, to find the inverse of a matrix, you must know a formula. L inverse will be 1 all over AB minus BC, 1 over your determinant, multiplied by the adjoint. And remember what's the adjoint? You always interchange A and D, and you change the signs of B and C. So negative B, negative C, that's the formula for the inverse. So let's make sure we can recognize matrix L. It is 9, 5, 3, 2. And what we're going to do is, we know this is A, B, C, and D. Yeah? Did we have to use L any time before? No. So therefore, let's substitute. This will be 1 all over A is 9, D is 2, both placed in brackets, subtract. B is 5, C is 3, both placed in brackets, times the adjoint, which is to interchange both A and D. So this is 2, that's 9, so interchange them. And I change the signs of B and C. So positive 5 becomes negative 5, positive 3 becomes negative 3. So this will simplify to become 1 all over 9 by 2 is 18, subtract 15 times the adjoint 2, negative 5, negative 3, 9. And therefore this becomes 1 all over 3 times 2, negative 5, negative 3, 9. And therefore, I'm going to multiply a third, which is known as a scalar quantity, by each element within. So I'm going to get a third by 2 is 2 thirds. A third by negative 5 is negative 5 all over 3. A third by negative 3 is negative 1. And a third by 9 will give me 3. And this here represents L inverse. Okay, so that's the inverse of the matrix L. Alright? Alright, so let's move on to part C. So I'm erasing here. Part C. So we have 10 part C. So we have, so we give it a vector. So PQ with the arrow on top will indicate that it's a vector. PQ has magnitude 5, negative 4. If P is the point negative 2, 3, determine the coordinates of Q. So P is the point negative 2, 3, and we want to determine the coordinates of Q. So how are we going to do so? Now, when we have vector PQ, 5, negative 4, that's a magnitude. Remember, if the magnitude is represented as a column vector, and 5 is the horizontal movement, and to the right, and negative 4 is a vertical movement downwards. Good? So if we have here, suppose I have, let me set up this, suppose we have here, right, let me see if I can set up this, Alright, I'm going to set up a grid so we can have a visual of it. So setting up this grid. Let's have a visual. And we have So quickly set up a grid. Right, so I have this grid here. And what I'll do, I'll let this be my let this be my y-axis. So that's my y-axis, and I let this be my x-axis. Right, so I have my y-axis, I have my x-axis. And this here it is 0, -1, -2. This here is 1, 2, 3, 4. This is -1, -2, -3, -4, -5. Right? This is 1, 2, 3, 4, 5. So we have this point. This point is -2, 3. So this is -2, 3. So that is our point P. So P -2, 3. And it says at the point P, they want us to determine Q, seeing that PQ, to the movement from P to Q, the magnitude of course will be 5, -4. And what 5, -4 means? So if P is your starting point, as you see from your vector, P is the starting, Q is the ending point. Yeah? Moving in that direction from P to Q, so P is your starting point. It means you're going to move 5 to the right. So this will be 1, 2, 3, 4, 5. And I'm going to move 4 downwards. So this will be 1, 2, 3, 4. So that's Q's position. Yeah? So when they ask us to move 5 to the right using the translation vector 5, -4, 5 to the right, 4 downwards, we know that the coordinates of Q, so the coordinates of Q will be 3 on the x, -1 on the y. So that will be the coordinates of Q. Alright? So just setting it up using a visual so you can see. So set up a nice little Cartesian pin, have that visual. You could have done that in your exam. Locate the point P and move 5 to the right and 4 downwards to identify Q. Right, so let's look at the next question. So this is D. So I'm erasing this. So we have here 10D. So 10D. Right, so we have a displacement vector question, and this is a vector diagram, and what they want us to do, it says here, this is a pentagon. So in the pentagon OABCD, OA is parallel, very important, parallel to DC, and AB is parallel to OD. Now it says vector OD is 2 times vector AB, and vector OA is 2 times vector BC. Right? So this is twice this, and OD is 2 times AB. Right? So let's say vector OA has magnitude A and vector AB has magnitude B. So what I want us to find in this question. Find in terms of A and B in its simplest form, 1, vector AD. So first let's find vector AD. So to find vector AD, what we're going to do first is ensure that we connect A to D. So we're going to draw a line from A to D first. Right? So I connect vector AD, and on that line I'm going to place the direction. The direction will be from A to D, because all vector quantities will have magnitude and direction. Okay? Now, to find AD, we're going to use the triangle law. And to use the triangle law, you want to ensure that you have the magnitudes of 2 vectors on that triangle to help you to determine the third vector. So the third vector in this case, of course, will be AD. We want to find that vector, but we must ensure we have the magnitudes of 2 other vectors on that triangle. And yes, we do. We have vector OA whose magnitude is A, and we have vector OD, because it told us OD, vector OD is 2 times AB. And if vector AB has magnitude B, then vector OD will have magnitude 2B. So vector OD, the magnitude will be 2B. Alright? And what I can do now is use the triangle law to help me to find AD. So using the triangle law, we always look to see which 2 vectors move in the same direction. Which 2 vectors move in the same direction. So OA follows AD. Now this is one way of finding AD. So you look to see which 2 vectors follow each other. The arrows will indicate that. OA follows AD. So once they move in the same direction, we add them. So you're going to say vector OA plus vector AD. And once you use this approach where the 2 vectors follow each other, you'll see when the 2 inner letters are the same, and you connect the outer letters in that order to give you OD. And therefore AD can be made the subject by subtracting OA from OD. So I bring OA over to the right and change the sign, and therefore vector AD is vector OD, which is 2B, subtract vector OA, which is A. Alright? So 2B minus A will be the magnitude of vector AD. Or you can have done it this way too, or some students, I'm sure, would have done it this way in the exam. To get vector AD, you can simply say vector AO plus vector OD will give you vector AD. And what is vector AO? Now this is vector OA, going from O to A. So vector AD will be moving in the reverse direction, opposite direction, but you'll have to change the sign of the magnitude, right? So AO will be negative A, and OD will be 2B. So AD is the same, negative A plus 2B, or you can write it as 2B minus A. If you want. So I can switch this around. Negative A plus 2B. So you got the same result. Alright? So that is AD. AD is negative A plus 2B. And it's always good to put the magnitude on the diagram. So let's look at the next part. BC. So to find BC, so this is part 2, this is part 1. So to find BC, what we can do, this is where you can implement what you call a polygon law. Polygon law. Now the polygon law is where you have a polygon. A polygon is a figure with more than with 3 or more sides, right? So this here is a polygon, right? So you can use this polygon here, or you can use the entire shape, the entire pentagon. Yeah? But I'll go with this simple, I'll go with this polygon here. But for me to use that polygon, I must have the magnitudes of all. If you want to find BC, you want us to find BC, so put the direction first. And if you wanted to find BC, we must ensure we have the magnitudes of all the vectors on that polygon. So we have AB, we have AD, but we don't have BC. Alright? And what it told us that OA is 2 times DC. Yeah? So if OA is twice DC, then DC, we can find DC. DC is a half of OA. If OA is twice DC, then if you make DC the subject, divide this side by 2 and divide OA by 2. These two cancel out. DC is OA over 2 or half OA. So DC, vector DC is a half of vector OA. And you know vector OA, the magnitude is A. So vector DC is a half A. So we know the magnitude of vector OA is A. So vector DC is a half A. So let me put the magnitude on the diagram. Alright? So now that I have the magnitudes of all my vectors on my polygon, so the polygon I'm focusing on will be BABC, right? So that's the polygon I'm looking at. What I'm going to do is to use what we call the polygon law. So to find BC, I'm going to say vector, so this is part 2, continuing here. So to find BC, I'm going to say vector BA plus vector AD plus vector DC will give me vector BC. So I connect my 2 outer. So vector AB, you realize only 2 inner numbers, in a letter, sorry. Let me see, AADD. So vector BA plus vector AD plus vector DC, and you connect the outer in that order, will give you vector BC. And vector BA will be what? We know vector AB, the magnitude is what? B. So if you want vector BA moving in the reverse direction, so you have to change the sign of the magnitude. So that will be negative B plus vector AD is negative A plus 2B. So we put negative A plus 2B in brackets plus vector DC is a half A is equal to vector BC. Alright? And let's simplify that. Let me remove the brackets here. This is negative B. Plus by a minus is a minus A. Plus by a plus is a plus 2B. Plus a half A is equal to BC. And now let me group like terms. This will be negative B plus 2B and negative A plus a half A is equal to BC. And negative B plus 2B will give me B. Negative 1B plus 2B is B. And negative A plus a half A, negative 1A plus a half A, negative 1 plus a half is negative a half. So I'm going to get negative a half A is equal to BC. So negative A plus a half A, when we group like terms, negative A plus a half A will give us negative A. And this will be the magnitude of BC. If you want to write the A first and then B after, this is negative a half A plus B is equal to BC. So BC is negative a half A plus B. That's BC. Alright, so this is negative a half A plus B. Okay? Yeah, and then they ask us next, state the conclusion about the magnitude of AD. So those two parallel lines on either side will ask us to determine what's the actual magnitude or size of the vector AD, and BC that can be drawn from your responses in 1 and 2. So what can we say, what can we conclude about vector AD and vector BC? Right? AD, we got AD and we got BC. So this is AD here. And this is BC here. And both we have on the diagram. So this is AD and this is BC. And what can we conclude? What can we conclude? So normally to conclude, what we're going to do, and let me erase so I can conclude the last. Right, so what can we conclude about vector AD and BC? Right? So we know AD about the magnitude of vector AD and the magnitude of vector BC. So what can we conclude? So we know AD, the magnitude, so that means magnitude, those two parallel lines, the magnitude of AD and the magnitude of BC. The magnitude of AD is negative A plus 2B. And the magnitude of BC is negative a half A plus B. So when we look at that, we can set up an equation to show that there's a proportional relationship between the two. Right? Because the question asks us, state what can be drawn from your responses in 1 and 2. What can be drawn from these two vectors? We can establish a proportional relationship between AD and BC. And to establish that, we can set up what you call a proportional equation between the two vectors. That's vector AD is K times vector BC. K is known as your proportionality constant. Good? It will tell us what proportion is AD to BC. And look how simple. Look at AD and look at BC. Isn't AD twice BC? If I'm to write AD, negative A plus 2B, and write BC minus a half A plus B, what can I replace K with? If I multiply 2 by negative a half A plus B, wouldn't I get negative A plus 2B? 2 by negative a half A gives me negative A, and 2 by plus B gives me plus 2B. So this will indicate to me that K is 2, and will also indicate to me that vector AD is 2 times vector BC. And it's right in the diagram. Vector AD is twice vector BC. So we can conclude, so when they ask us to state what conclusion, so we can conclude that vector AD is 2 times vector BC. That's what we can conclude. That vector AD in terms of the magnitude. We can conclude that vector AD is 2 times vector BC, and that can be clearly seen in the diagram. Alright? Alright, so this will bring us to bring us to the end of the paper. So, so I hope we all looked at the steps, and we would have implemented the same steps in your exam. And once you did so, then clearly you'll be put in a very good position to pass with a distinction in your examination. Yeah. Again, you have the multiple choice. So next step now is to work on your multiple choice, so you can be put in an even better position to get your distinction. All right. So going to end this session now. It was a pleasure working with you all, and you all benefiting from this exercise to see the solutions of June 2024. And I want you all to have a great night. Stay blessed, and I'll see you all next time around. Take care.